I have no idea what Willem's talking about. I never have these problems. Today aside, right? Anyway, quick agenda. I have a little bit of, I guess, philosophy. I don't know. I don't want this to sound too self-helpy, but it's going in that direction. And then the classic ham, I can't hit the repeater and I don't know why. Followed by a couple notes about WinLink, because that seems to be the Aries classic, it's broken. And then Willem shared a war story. I will share as many war stories as it takes to fill up the time. If others have some they want to share in the room, that's great too. Anyway, how can I or anyone else possibly be qualified to talk about this? Yeah, I'm not. I'm not at all. I do computing for a living though, and I get a new machine every couple of years that is totally broken. So I kind of do this for a living, and you saw that I have good luck with electronics. So yeah. Willem and I have also gone to a couple events and been frustrated with people's ability to troubleshoot or lack thereof. So there's a need, and despite not having any idea how to approach this, I'm doing it anyway. So let me know what you think, and yeah, if there are questions, just please stop me, because I have some material, but we'll see. So anyway, what's troubleshooting? The basic idea is figure out what's wrong with something, and it's key here, right? Figure out what it is doing and what it should be doing and how they're different, and people forget that sometimes. No actual shooting, though. No holes in things, usually, but that'd be really therapeutic, because nothing ever works. A few approaches, right? Pattern matching seems to be what people do these days. Throw it into Google, hope for the best. You can try science, scientific method. It's a lot of work. Nobody does that, but we'll get to that. There's divide and conquer, and as someone who occasionally mentors undergrads, random guessing. Change stuff. Change more stuff. Hope for the best. I hate that. Don't do that. Well, plug a different computer in, right? It can be efficient, but you don't learn anything from it, and it's not very repeatable. So anyway, this seems to be the standard 2020s approach to troubleshooting. Pick some random symptoms, Google them. Is it fixed yet? Google some more things. And this is great, except sometimes Google doesn't help you. So, and you also need to know how do we even know it's fixed? So a lot of times people don't know what to expect from their system. You have a system, you key your radio, I guess you expect that something happens at a repeater somewhere or something happens at some other radio. But is it the right thing? Is your audio getting there? Is, whatever it may be, right? So it really helps to think about what you're expecting to happen. And then, is it doing that? Great. If not, well, we should figure out, right? Do you know what it should be doing? So how do we approach knowing what it should be doing? I like to think of this in terms of abstraction, right? Well, we have a radio system. That's pretty abstract. Or I have an AV system, which, as you can see, is a big pile of gear in a rack, 2 monitors, 15 zillion different encoders. Well, it's broken, great, but can we divide that up a little bit and can we find what's broken? So can we cut down to a lower level of abstraction? Okay, the radio system is broken. Well, what could be broken? Your radio, your antenna, your coax, your power supply. Go down another layer. CPUs, amplifier, final transistors, display, whatever it may be, buttons. So the idea is to find the lowest abstraction that you can, the smallest piece that you can prove is not doing what it's supposed to be doing. And a lot of times we may not know what some of these components are supposed to do. So that's fine, but find the smallest piece to attack that you can for sure guarantee is not working. And we can do that through measurement, right? But prove that the rest is working. A lot of times people say, well, the power supply's fine. The power supply's always fine, right? It sits in the corner, it does its thing. Are you sure? So the random guessing, the pattern matching works to an extent, but when it stops working, the thing to do is to verify every component, right, to the best of your ability. And we may not always have the tools for that. So I'll show a couple of measurements you might do for some things. There was another measurement talk, what's his name, Bob, earlier in the year. That was fantastic. There should be a recording on YouTube someplace. Father Willem after. For some more ideas there. So anyway, how do we expand our approach here? Well, Google the symptoms. Is it fixed? No. Shrink the problem. Find a smaller piece of the system that is still broken. Google more symptoms of the smaller problem until you run out of smaller problems that you can definitely prove are broken. This is all really, really pretty obvious, straightforward stuff, but people are not methodical about it, and so you end up floundering, especially in higher pressure situations like I have 10 minutes to make the video work or else. Of course, there are some other approaches than just Googling, right? And one that we as hams like to apply a lot of times would be heuristics. And a heuristic is just an imperfect way of classifying something, in this case, a problem. Maybe you've seen a similar problem before. Maybe it's always the same problem. As a computer scientist, it's always DNS. Yeah, Chris knows. For radio folks, we only care about the network, so it's usually connections or power or something has gone up in smoke because you left it out in a thunderstorm. Don't do that. So heuristics you might try in radio or electronics, right? Wiggle the connections, wiggle stuff, shake it. Things tend to come loose mechanically, and that can be thermal cycling, or it can be you didn't plug it in all the way, right? These fancy magnetic connectors, you look at them funny and they stop working. But if you leave a piece of coax out in the weather for a year, you give thermal changes, you have corrosion, so sometimes just plug it in and unplug it, that sort of thing. Check for power. Did you plug it in at all? Are the batteries good? That's 80% of it for me right there. Check for burned stuff, or those of us in computing, water leaks, right? Obvious physical problems.
Do you smell smoke?
That's the next one. Yeah, do you smell smoke? A lot of times the burned stuff is inside, but you will smell the residue of the burning. So if you see somebody that's been an electronics test engineer, a lot of times they will be smelling circuit boards, and it looks weird, but it's very, very effective. Likewise, if you're troubleshooting something that's plugged in and live, maybe the fire hasn't happened yet, but it's about to. So IR cameras are good for this. Or I had an internship in high school doing electronics repair, and I was told there's a definition for ouch hot that's about 120 Fahrenheit. So you can measure temperature that way, right? If you stick to it, it's too hot. I've done that. If you can cook on it, that's not a good sign either. I actually had this argument with a computer vendor last year. Oh, 110C, that's fine, that's normal. It's under the melting point of the silicon. Don't worry about it. So yeah, these are all really simple things, but a lot of it comes down to situational awareness and just look at the problem a little bit, and a lot of times something obvious will happen. Same thing with mechanical issues, right? Are there dents, cracks? Has someone grabbed the circuit board and done one of these? It happens, right? Especially bigger circuit boards, if you pick them up by one corner, they'll crack. Chips will fall off. Are there chips that have fallen off? If there's a row of little legs where the chip used to be, not a good sign. And of course, it's always X. It's always power. It's always the antenna. It's always whatever, right? And if you've worked with a system for a period of time, you start to get a feel for what it always is. Of course, that's only a heuristic, right? It's something to try. It's a first step. If it's not that for whatever reason, you have to dig deeper. And a few more, right? Did you try turning it off and on again? Those of you who've seen the IT crowd, you pick up the phone. Did you try turning it off and on again? There's so much truth to that. I like to say, did you try physical violence? This actually can work, right? throw it across the room. It's very therapeutic, and again, things get loose, right? It obviously depends on the robustness of the system and what you're troubleshooting. So, not responsible for broken stuff. After you have done that, did anything fall off? Well, that part was loose. That's your problem, right? So, pattern matching, right? We can replace Google with try some common things, but still reduce the problem. And once we're out of common things to try, then we can go to Google or your new AI assistant. That seems to be the thing the last few weeks, if you're following the tech news. And if it's fixed, well, great. If not, we can dig more, right? And another good heuristic. Obviously, this has not always been a problem. I mean, maybe if you just bought a new radio, it doesn't work. And of course, the problem is you in that case, right? You don't know what you're doing. But assuming this machine has ever worked, whatever it may be, the obvious question is, what did you do to make it not work? Stop doing that. Again, very obvious piece of advice, but it comes down to being methodical. In a lot of industry, you will see people log things, right? Every time you make a change, you log it, and that's, or in computer science, right? We have commit logs. Every time you make a change, you can go back a step. And if you enable that while you're troubleshooting, that will save you a lot of time because you can go back to a known state. Every time if you just randomly change stuff, you don't know what you've done. You don't know, maybe you had it almost right and you've now made 15 irrelevant changes and one that's going to make it worse somewhere in the middle. Which one, right? You've gone from one problem to two problems. That's not helping. So think about what you have changed since it last worked or since it was last in a known state and keep track. Again, I can't stress enough. Be methodical about this. Take notes. Do whatever you need to do. And then, once I get this page a lot, and it actually turns out there's a URL you can go to force it to give you this page. You can ask Google for no results. But I kid you not, number equals 0. But I get this page organically pretty regularly, right? So, this happens. All right, now we're in hard mode, right? Manage complexity, take notes. What have you already tried and how did it impact the system? Did it impact the system? But, science is really hard. So are there some other ways we can trick ourselves into figuring out a solution? In computer science, we do rubber-duck debugging, right? So you have a stuffed creature, and I don't have any ducks, but people keep giving me these stuffed birds. So I have a bunch of those. And explain the problem. You don't actually need a human, but explain the problem. A lot of people write emails. If you write an email to a friend saying, I have this problem, it's doing these things, it's been doing it since Wednesday. On Wednesday, I also changed and bought a new power supply, or I changed the batteries. Here's a hint, right? This is just a mental trick to trick yourself into thinking through the problem, right? So explain it to the stuffed animal. And the stuffed animal probably will not ask smart questions. But, think about what the stuffed animal might ask. Or, if you're doing this for a fellow human, just sit there and ask dumb questions. Why does it work like that? Why did you do that? Explain it like I'm 5. What normally goes wrong? What went wrong this time? How is it different? Why is it on fire? Where's your fire extinguisher? And this comes down to something that management folks like to call the 7 W's, right? Why did it happen? What is happening? How is it happening? And if you sit there and ask yourself these questions, a lot of times the answer will just come, right? You think about it and you come up with something you didn't try. That's a pretty powerful technique. Of course, sometimes you're still stuck. You really sure, though? You run out of heuristics. You've tried calling for help. All right, fine. Brute force. And the goal here is to ensure that nothing could possibly be wrong. Take the system apart, check everything. And that comes back to abstraction, right? Maybe the only thing you can check is, does the whole system work? Well, then you should go find someone who knows more about the system or do some research. But take it apart, and maybe we can check that the antenna works and the radio works, and fine. All right, so the radio doesn't work. Can we take that apart? Can we check that the finals work? Can we check that the fuses are good? You know, whatever it may be, right? And you just keep recursively taking it apart. And as you take things apart, we need to measure them, and we need to know, is it doing what it's supposed to be doing? So, you know, you have a power supply, right? Is it producing power? You spark the two wires together or something. Yep, some power. Again, not the best measurement technique. To quote Bob, if you can see the electrons, you're doing it wrong. Sort of, paraphrasing. But, all right, can we do a better measurement? Well, is the voltage, whatever the voltage is supposed to be, is it 13-ish volts for a lot of radio systems? Can it produce enough current? So everything you can measure to the greatest degree of precision that you can pull off. And usually that will work. Sometimes you'll have to buy better tools and go more precision, but usually not. And think about anything external that can impact the system too, right? Weather, phase of the moon, and you laugh, but that happens, right? Things like, did you leave the radio outside and it's really hot today and it's getting warmer? There's a repeater down south that was having that problem a couple summers ago, right? It was fine in the winter, and then in the summer, the little building thing it was in got too hot and it started acting up. So it's not always really direct things. It can be external factors, let's say. So, you know, measure those too. Does it always break on a Wednesday? Does it always break when it's hotter than 80 degrees out? Whatever it may be. And since we're out of heuristics at this point, all you can do is measure everything. Anything you can think of. And then we can try to correlate that with the behavior of the system. If the system misbehaves consistently when something else is happening, figure out why. Everything? Yes, everything. And yes, this is a lot of work. But, yeah. All right, so hard mode troubleshooting. Understand everything about your system and everything that could impact your system. Choose a thing, prove that it's not the problem. If at this point you have fixed the system, great. If not, choose another thing and prove it's not at fault. And by prove, I mean prove, right? Go look at the schematic. If there's supposed to be 2 volts there, make sure there are 2 volts there. And make sure there are 2 volts there under whatever condition you expect to use the system. You know, maybe the system behaves different under transmit. Usually, in fact. And how do you go about this? Well, it depends, right? Some of us go and spend $100,000 and get engineering degrees. Some people read books. Some people go ask experts, and there are certainly some of those in the room here today. Don't know why half of these people care about this talk, but that's cool.
Because we're crazy.
There it is. You'd have to be, right? And a lot of it comes down to experimentation and critical reasoning, right? So I will show a couple experiments in a minute, but if you're not sure how the system behaves, design an experiment that will prove how the system behaves. You know, the demo I'll show in a bit is, well, do you have your tone encoded right? Is your Chinese radio with its Chinese menus sending out the right tone? Well, put it on a spectrum analyzer and see if it's encoding a tone. But how do I know what tone it is? Well, I happen to know how FM works a little bit, and you can look at the sidebands and figure it out. But maybe adjust the tone, see how the system changes, and now you can learn how FM works. So you don't necessarily have to know a whole lot about this. You can design experiments to show you how the system changes in response to certain inputs, and both learn a lot and often solve the problem. So you've measured everything. Everything is perfect. to the documentation standards, right? Whatever that may be. Maybe you have a schematic, maybe you have a textbook, a theory of operation, whatever it may be. Everything is perfect. Well, there are two possibilities. One, you screwed up. It's not perfect, but you're bad at measuring. I'm bad at measuring. Measuring deliberately is really hard, especially at RF, right? RF does things like changes its properties when you look at it funny and bend the cable, or leave the antenna too close to the ground, or have another antenna near too close, right? All kinds of, you look at RF systems funny and they change their behavior. Very annoying. The other possibility is that you haven't measured accurate, or you haven't measured the right thing or enough, or that your expectations are wrong. So a lot of times documentation is wrong. Engineers don't like documenting things. I know, heresy, right? So if you have 100% proven that the system is behaving according to your expectations are probably wrong. This is, of course, a little bit of a difficult thing to troubleshoot. Go back to the theory of operation. Think about how it should work or how it could work, right? If you've got your light bulb and your battery and you've got some wireless wire there, but the system says that it's fine, right? The electricity will jump from one side to the other. Totally fine. Think about that a little bit, right? Electricity only jumps maybe a centimeter per 1,000 volts. So if you're using a reasonable sized battery, probably there will not be much jumping, and we should consider facilitating that a little bit, wire. So, reason about how the system should work, and the documentation is a fantastic starting point. There should be some, this is something that ham companies seem to do pretty well, right? You buy a shiny new radio, a lot of times it actually will come with the schematic, which is strange and lovely. In other fields, sometimes the schematic is tucked inside the case of whatever. They figure if you're dumb enough to open it up, then you can have some hints. I've seen that in appliances a lot. And sometimes there just is no documentation. But yeah, you can either make your system look like your expectations or make your expectations look like your system, right? Redefine success. Of course, but we don't know how it's supposed to work because we're amateurs, right? We don't know. I don't know anything about radio. I'm not admitting to it anyway. So you don't know how it's supposed to work. Well, fix it. Fix that, right? Channel Sesame Street. One of these things is not like the other. This is another solid heuristic. Look at the system. Maybe I have two radios, right? I borrow one from Willem. Willem's works. Willem's nice to his equipment, right? How is mine different? Well, mine has a big burn hole in the middle, right? It's a big tip off, but maybe we can also measure things. We can look at the output of Willem's. We can look at how much power Willem's draws. We can look at how warm it gets, whatever it may be. Anything you can measure and compare or look for anomalies. And this can give you a direction without necessarily knowing much about the system. And I was going to do war stories at the end, but we'll do one now, right? Like I said, I do computing for a living. And we buy machines from a vendor, and then we have to support them after they're delivered. And the vendor always says, oh, the machine is fine, that's normal. Don't worry about it. It's fine that all the different components are configured in different ways randomly, even though they're all identical. And, it's located in another state. I don't get to look at it, so I have to measure things indirectly. And, one day, we're looking at some pressure graphs on the cooling system, and all of a sudden, the graph goes from this nice little noise squiggle to sawtooths. Turns out that a sawtooth wave means that you are, in this case, pumping water out onto the floor and then refilling it from a makeup bag and then slowly pumping it out onto the floor, refilling it from the spare makeup bag. And, nobody noticed, right? Nobody's looking at this thing. So there's a puddle of green slime on the floor, but it's fine, right? And, the vendor's like, oh, that's normal, whatever. We never look at that, it's fine, don't worry about it. Puddle. But how did I identify this problem? Well, certainly not by noticing the puddle, by noticing that something had changed. Something was different, right? This part of the system is doing this weird sawtooth thing, and everybody else is just, a little bit of fluctuation in the pressure sensor, noise, whatever, right? So the key here is notice things that are strange. You don't have to know what they mean, but notice that it's strange, and then go try to understand the strange thing. This is, I mean, it's a skill, right? Like anything else. You get better at it over time. And it comes down to, again, how do I even know it's broken? Well, if you've noticed something strange has happened, maybe it's not broken. But understand why it's doing the strange thing, and then, either fix your expectations, the strange thing is no longer strange, or fix it. And, we can do this by finding another one to compare to. So if Willem's is doing a strange thing and mine is not, that's concerning. If they both start doing a strange thing because it's April and it's nice out all of a sudden, maybe that's normal. So anyway, whipping through this faster than I intended to, but basically that's the end of the theory. Conclusions here: heuristic pattern matching, good, nice, fast way to do things, right? Is you may or I don't know if when we started streaming, but for those in the room, you saw during the beginning, right? The heuristic was the computer is at fault because they tried it earlier and the rest of the system works, and so we were able to very quickly solve the problem by getting another computer. But when that fails, methodically measure everything you can, right? To the maximum precision that you can. Find out as much about the system as you can, understand how it should work and how it is working, and compare those. Right? The key is comparing and being able to compare and having a reference to compare to. So hopefully that makes sense. Willem, I don't know. I know we normally do like 2 intermissions. I figured maybe this is a little early. I kind of figured this was a logical place to do it. Cool. So before we start back up, any questions come up? Surely I must have missed something. No? All right.
What did you do about the spill, the green goo?
I'll let you know when we figure it out. Oh, yeah. I mean, as it turns out, there was an O-ring missing from manufacturing, but this stuff comes up pretty regularly. It is amazing how much plumbing goes into computer science. I should have gotten a plumbing degree. It would have been more useful. Yeah, yeah. It's basically ethylene glycol. It's the same stuff you use in cars. The facility manager likes to call it alien blood. All right. So case studies. I was going to do WinLink to death, but the coverage on that is pretty poor, and Willem talked me into doing repeaters as the simpler thing that, trips up every new ham. So I'm not gonna promise to tell you how to program your radio, but I will go way into the weeds on how to debug your radio once you've programmed it incorrectly. So, again, it's always the easy stuff except when it's not. So before we go into this, just practical bit of advice, right? Make sure you've done all the programming right. Before you go into the weeds, you'll save so much time. However, anyway, the scenario is you just got a new radio, HT, mobile, whatever it may be. I was going to say mobile because mobiles are easier to troubleshoot, and then I realized I didn't have big enough attenuators. So take your pick. Anyway, you can't seem to talk to anyone. Could be some reasons for that, right? Maybe you've programmed it wrong, usually, right? Maybe people aren't very friendly. I know I was feeling bad because I was doing errands yesterday, and listening to someone incessantly call CQ on 5.2 for like 45 minutes. But I was in and out of every other store, so, that can happen, right? Or because your shiny new hardware is broken out of the box, which that would be me. That's how that goes. Anyway, what to do, right? Like I said, I'm going to go way into the weeds here. You've probably programmed it wrong. It is almost certainly you, but never know. So anyway, what do we know? Well, hopefully we know how repeater systems work, and we'll get into that a little bit. We know we can't seem to contact anyone or get any feedback from the repeater. We don't know why.
It's broken. It's always the broken system.
It's Maxwell's fault. You haven't been on your little four-wheeler up to the top of the mountain lately enough, or recently enough.
It's on its way to MRS right now.
I'm not terribly surprised. Anyway, we're going to talk about regular old analog FM. Willem and I went back and forth on whether we should do DMR, and I figured DMR was a little bit detail intensive, let's say. And yes, I know this is... I don't know. If you leave the DMR radio out in the thunderstorm long enough, that might change. This is Colorado. Lightning proof, though. No. Yeah, no. Get me a lightning proof radio and then we'll talk. And yes, I know this is a DMR club, and no, I don't care. And we know we have enough power to run the UI on the radio. We don't know we have enough power to use the radio. We know we have enough power to turn on the UI, right? Because that's obvious. It turned on, the lights are on. More on that in a second. So, how do repeaters work? You do know that, right? And no judgment if you don't, right? Again, trying to be new ham friendly here. So we send a signal out into the ether that hopefully the repeater can hear. Again, that's an unknown, but we think the repeater can hear it, and it resends it on a different frequency. Usually there are some filters involved so that the repeater isn't listening to itself scream. Not necessarily, though. I know there's at least one repeater in New York that uses separation, right? You have two hilltops, an antenna on each hilltop, and lots of coax. And that can be useful because filters are expensive and they get ridiculously large at 10 meters, 6 meters, whatever it may be. We usually transmit a tone or some access control code, let's say, in order to make sure the repeater knows that we mean to talk to it. I know the Fun Machine, I'm a Fun Machine board member. About 2 summers ago, there was an issue where we had feedback between a repeater in Kansas and a repeater here because the splits are opposite. So the Fun Machine was transmitting, and there was enough tropospheric ducting that a machine in Kansas was hearing it and repeating it back on the other side, which we were receiving, and so on and so forth. Nothing good comes of that. So one way to solve that is to use different access codes, right? Different tones, usually. And sometimes the repeater will beep or do something to indicate that it heard you. Sometimes it won't. So again, right, make sure we have the proper expectations. If you're going to sit there and kerchunk one of the systems in the state, and there are a couple, the Fun Machine's one of them, that doesn't have a courtesy tone and get upset when there's no courtesy tone, you will drive everyone around you nuts. Stop doing that. What about the radio? Well, radios are devices that slap electrons around in a piece of metal, and then magic happens. Like I said, I don't know anything about this. At least I'm not admitting to it. Right? By wiggling the electrons here, we can wiggle electrons on somebody else's piece of metal and communicate. Right? And if we wiggle them in certain patterns, we can transmit data. That's really all we need to know. It's magic. And a lot of troubleshooting comes down to taking magic and reducing it to magic plus X, right? We need to know just enough about how it works to find the problem. And it can be very iterative, right? You scrape the top layer off and make that not magic and prove that it works. And if it does what you expect it to do, great. And if not, you scrape another layer off the top. So, heuristics. We hit this again a minute ago, but did you try turning it off and on again? Is there physical damage? Are you pushing the right buttons? This is the one it's going to be. Are you on the right frequency or memory channel or whatever it is you may be doing, right? Nothing helpful in the list of heuristics? Good, because that would make the talk really short. I told Willem 3 hours. I'm not actually going to use 3 hours, but I told Willem 3 hours. Are you even sure it's not working? Well, how do we know if it's working, right? The radio should be producing some RF energy. And how do we know if RF energy is coming out, right?
Stick your tongue on the antenna connector.
Yes. No. Don't sue me. No. I'm told RF burns hurt. I have not had the pleasure, but several people have told me RF burns hurt.
I have several. I can confirm that. And they never go away.
Never?
Nope.
They're the gift that keeps on giving.
Well, that's fun. So don't do this. Or if you do this, very low power.
5 watts is enough to scar you for life.
Very low power. So just to be clear, no. But if we can't perceive something through our own sensors, I guess, let's say, we can find some tools and hopefully not kill ourselves. And yeah, again, to paraphrase Bob, right, if you can directly observe the electronics, it's usually not a good thing. One way to do this is with a power meter. These are fairly cheap. I'm sure HRO down the road would love to sell you one. They've sold me a couple. These fancy needle ones don't like hiking.
They also don't like static.
Interesting. I haven't killed one that way, but I have killed one by taking it backpacking.
Rub it with a cloth and watch the needles go crazy.
Ah, cool. Actually kind of makes sense. You can get digital ones, but they cost more money. So, you know, take your pick. And so, for the microphone, it's being suggested that you can use a static charge cloth to move the SWR needle where you want it to be. So this comes down to measurement mistakes, right? This is a fantastic example. Are you measuring what you think you're measuring? And I haven't seen that example, but I have certainly been tripped up by similar ones. One way to get around this is to try 2 different measurement techniques, right? If you have 2 identical meters, that probably doesn't help you unless you've taken your meter backpacking like me. I keep going up repeater sites with gear and places that you can't drive. But if you have an analog one and a digital one and they totally don't agree, well, now you've accumulated another problem, right? Now you need to troubleshoot your meters. So, yeah, 2 watches, you never know what time it is, right? However, it is good to know that your meter is lying to you, one of them. One way to handle this is voting, right? Get a 3rd meter. Best out of as many as you can afford. Yeah, good tools help, right? That's really the takeaway here. Other things we need, right? Some cables, maybe a dummy load that are known good, and we'll talk about how to know they're good. If you have broken tools and you don't know it, then you're going to get really confused. Of course, this comes back down to being methodical as well, right? I tried it on Tuesday with power meter X and it looked good. I tried it on Wednesday with power meter Y and it didn't look good, but either way I couldn't get a signal out. Well, maybe we want to think about our power meters, right? And being more methodical than you think you need to be can really help because you don't know what you don't know. In this case, that your power meter is broken. Anyway, yeah, how do you know your test setup is good? Well, you don't, and you never will. Give up now. No. You'll never be sure, but we can test it. And of course, to test it, we need more tools. And if we have more tools, we need to test our more tools. And this can snowball a little bit. For economic reasons, at some point, we usually decide that some level of tool must be good, right? And if you want to, you can try to compare tools and you can try to test them against each other, right? Maybe you have your VNA and you have a calibration load and it says your calibration load is 50 ohms and you trust your calibration load. So you then can use your VNA to test your dummy load and it should also say 50 ohms. And because they agree, we're pretty sure they're all good. Now, if they didn't agree, is it the calibration load or is it the other one, right? Well, now we need a 3rd one to do voting. So this really snowballs. But if you can prove that you have kind of 2 consistent measurements, you're probably good enough. And you can also just hope for the best. And hoping for the best will typically work if you buy good tools. If you buy cheap tools, good luck. And the definition of cheap can vary, right? It's a spectrum. So rudimentary pretests, right? You've got a broken system. It's always connections. It's always cables. It's things that mechanically bend. Use your own meter. Make sure your cables pass electricity, that they're not shorted. Why do we do this first? Well, it's really easy. Do things that are easy first. Use your VNA or your antenna analyzer, whatever you may have. VNA, vector network analyzer. We're measuring RF properties of the system. How filters respond, or in this case, the filter might be the cable or your dummy load. If you don't have one of those, hams like to call those antenna analyzers, and antenna analyzers are the same thing, but they show less stuff. And they cost just as much at this point, so I don't know why you'd do that, but they used to be cheaper. And of course, physically inspect everything. A lot of radio gear gets left out in the rain or the thunderstorm or whatever it may be. So you can save yourself a lot of grief and time measuring by noticing that there's a hole in your coax or there's water pouring out of it or whatever, right? Drip loops are good. So when all else fails, we can measure things. And this little device is something called a nano VNA. These are like $100. Be careful not to get a counterfeit one. So this was a nanovna.org, I think. And I apologize for the terrible screenshot. Apparently, nothing likes big SD cards. That was kind of a theme writing this talk. My Spectrum analyzer refused any flash drive I had. The nano VNA refused any micro SD card I had. So I finally gave up and just took a picture of the darn thing. But what we're looking at here, I have this displaying reflected power. So it sends out a small signal and measures the reflected power. It's in single port mode. You can measure something through a system with these too. So that's one thing that makes a VNA more flexible, right? We can measure through a filter, through a cable, whatever, or we can measure reflected power. And we can see that it's determined that this dummy load is 50-ish ohms, and it depends on frequency because the real world is messy. So, you have to try to develop some understanding and some intuition for how these things work, right? This thing says it's 50 ohms from DC to 3 gigahertz. Well, it was also $100 on Amazon. And it's 50-ish ohms. But in practice, it doesn't really matter, right? We don't need 50.000. We need, 50, give or take 10. And we would also expect that there would be, terrible video, very little reactance. And, there's an ohm and a half or something, so that might as well be 0 for our purposes. So good enough, right? And we can do the same test with a real antenna, and I was going to do it, but I ran out of time. So if this were a real antenna, you would probably see that there would be a dip to about 50 ohms, about where you expect the antenna to work, and other things at other frequencies, right? This frequency, resistance, reactance. So anyway, what is this dummy load thing anyway, right? It's an expensive, high-powered resistor. And it's hopefully at the characteristic impedance of your system, if you have the right one. Hams, we assume the world operates at 50 ohms. Not necessarily the case, so make sure you buy the one for the characteristic impedance of your system. If you're playing with ham gear, just 50 ohms is fine. And like I said earlier, antennas are magic. So if we can eliminate magic from our troubleshooting, that's a good thing. So the dummy load is a little bit more of a predictable thing than an antenna. The bird lands on the antenna and its impedance changes. We don't want to be having variables like that while we're troubleshooting, or the wind blows or whatever it may be. And also, someone who's a little bit in the repeater community, your dummy load hopefully isn't radiating much. It will radiate some. There are always stories of people that are doing transoceanic contacts on their dummy loads or their light bulbs or whatever it may be. But it's at least considerably better than using a real antenna, and you are less likely to annoy your neighbors if they're also hams. So yeah, again, enough with the Kerchunking. Of course, if you have access to an RF-proof chamber, then go to town. But I don't know anyone that does. I don't know, maybe Doug does. But if you're in that boat where you have serious test equipment, where test equipment means building, why are you here? I'm not that entertaining. So anyway, how do we test power, right? connect the dummy load to the antenna port on the power meter, connect the other side of the power meter to the radio, key the radio, hopefully something happens. There should not be much reflected power because you have 50 ohm coax, 50 ohm dummy load, 50 ohm radio, right? If that's not the case, then we have something to investigate, right? Maybe the cable is reflecting some of the power. Maybe your dummy load's broken, but it's not because we just checked it. We just checked the cable. Of course, there are some traps with this. You have to actually be putting out power. You have to understand the system enough to know that you are actually putting out power, that your expectations are correct. So in amateur radio, the trap here is single sideband. Single sideband is a suppressed carrier kind of modulation, right? There's no energy sent, or not much generally. Yes?
There's a comment here on the chat, which I missed, from Doug Sharp. He says, one trick I use on my Bird 43 watt meter is to short out the meter during transmit. Many watt meters use a micro ammeter movement. Short it out while driving or hiking. It will last longer.
Fascinating. I thought I saw Doug's truck. Where is he?
Mark drove it.
Ah, that would do it. Very confusing. Yeah, thanks for that, Doug. John, are you mic'd, or should I repeat that? Okay. Yeah, so single sideband, you can key down all day, and if you're not producing any audio, feeding any data into the system, you won't be producing any energy or much energy. Comment, Willem?
On that point, many meters will not go into either AM or CW mode. They're sideband only on the channels. And so most of your antenna tuners will not be able to tune up, because how most antenna tuners work is by triggering an AM carrier so that there's enough energy that it can actually tune the antenna. So if you're on 60 meters and you want to tune your antenna, you have to go duh into the microphone so that you put out enough of a signal that the antenna tuner can actually tune the antenna. And it will actually tune the antenna, especially if you have one of these LDGs or one of the other third-party tuners. So apropos of that particular problem, you can actually use those on 60 meters, but you have to know what's going on.
It's all about understanding the system enough to know where the traps could be. And that's fascinating. I hadn't come across that, but 60 meters is a lot of meters for us apartment dwellers. I do, but if I string wire across the woods, I have interesting questions from the landlord. Like, why is there wire across my woods? If you're not as talented as Willem at producing audio, usually you can put it in FM or CW mode to get the radio to produce some sound. Apparently not on 60 meters, though. Learn something new every day. That's why these talks are fun. But yeah, the moral of the story here is to make sure you understand what should happen. And if what should happen is nothing, then when nothing happens, sometimes, you know, people get confused, right? So, all right, you don't get any power out of the radio, now what, right? Well, it could be that you're not making enough noise. So, I don't know, whistle? Or I suppose if you're making the wrong noise, you could get the voice filters or the compressor or something to not help you. You might not be supplying enough power, right? Garbage in, garbage out. That seems to be another fairly common one. Of course, batteries and power supplies have internal resistance. And that can change over time, especially with batteries. If the internal resistance of your power supply is changing over time, stop leaving it out in the rain. But you may not have adequate voltage. You may not, whatever, right? Or your radio could be broken and we could need to open it up and look into its insides. But let's assume for a minute that it's a shiny new radio and it works. So the obvious thing everybody tries is measure the voltage of the power supply. Is it about 13.8 volts for most of these fancy new, you know, DC powered radios? If so, well, that's a good sign. If not, could be a problem, right? But the properties of power supplies also change under load. So you measure your voltage under load and, key down. And again, you need to be actually putting out RF energy you're trying to. So you start whistling into the microphone again, I suppose. Yes.
13 volts. 0.8 is always 13. I'm guessing that.
Mike.
Oh, thank you. I'm not sure this is worth recording, but 13 volts, 13.8. All your documentation says run your equipment at 13.8 volts. And I'm assuming, that most of these are mobile systems that we're using. You can plug right into your battery. Well, your alternator may not be running. You're not going to be running at 13.8. It's not uncommon to be at 12.7, 12.8, 13 volts. How crucial is that number?
There should be a second number in the spec sheet that tells you exactly that. It will be 13.8, give or take 5% or 10%, or give or take a volt.
A volt's a big deal. So that's a lot of variance. Sorry?
Yeah.
I'm sure. I'm sure. Well, like I've got a 12-volt battery bank in my home shack that's running on a solar panel. During the daytime, it's going to be over 14 volts, but at nighttime, it's going to settle down to resting voltage. And that's when I'm wanting to use it a lot.
And a lot of these radios are designed to be run in a car, so they are designed for the range that cars put out. So 13.8 is nominal while the car is running.
Yeah.
So, probably 12 and high change through 14 and low change will work.
I mean, I'm aware that it's not going to damage the equipment at all.
Well, it might.
Really?
It depends what you have.
It's going to affect how far you can broadcast as well. And I'm wondering what kind of difference that is, if anybody even knows.
It may or may not. It depends on how the power electronics in the device are designed, right? This is totally device specific.
Some of them actually have voltage multiplier or a regulator inside that, like from 11 to 14, but inside your radio, it's fine.
Oh.
It says, oh, I like you, I'm going to give you full power. Depends on the rig, but going on 5 years out of license. 12 volt, it wasn't until I was in my 30s I realized it was a thing called 13.8.
Well, don't worry about it too much.
But I have a Kenwood in my car that will absolutely refuse to run at anything less than 12. So it really depends.
I hooked up my FTA-17 to a solar panel without a regulator. Whole display's flashing like this. I realized, wow. When I looked at the display, it says 19 volts. Okay, I better turn this off.
Right. That's
Yeah, there's another commenter.
So I've got a Yaesu FT857D, okay? And it's, in the manual, it says 13.8 volts, and as you reduce voltage, it will actually start cutting out transmit power. So it's not a binary, it works or not, it's this down to this. And the radio will work on 9.5 volts, just won't transmit anything. But there's a depth, pardon?
how much you lose at, say, 12.7.
Well, it'll go down to 5 watts if the battery's down, and if things, it can get that little amount of juice out of it. And then also on the back of there's a little red wire, and somewhere in the manual explains what that does. You cut it or you keep it, and you can get it to do that or not. So very important to understand to his point how much is available, because it makes a huge difference. And in some cases, it's not a binary yes or no. It's we're going to start reducing. So you get 20 watts out of a 100-watt radio, and you can't understand why, because the batteries run down.
Those Yaesu radios are also notorious for starting to splatter with the voltage on them. When the voltage is low, it'll start to splatter, so the signals will start to distort.
That brings up a good point. Doug Sharp has a comment in the chat here that says, a good radio has regulators inside to regulate the voltage. What they don't like is low voltage.
Low voltage being under 12.
It really,
Usually most radios are plus or minus about 5%. Once you start getting below that, and I have a radio that freaks out at 11.7. So in the high 11s, they try to build a lot of the new stuff to work with solar, and most cutoffs on batteries for being at 0 volts is about 11.3 to 11.5. So generally above that, they'll be okay. If you start getting below that, things are going to freak out.
Yeah, I know, and I've used it's a battery booster. I know PowerWorks has got one that will, if you put 12 volts in, and if you need, it'll keep the voltage up to 13.7 or whatever the set point is. Sometime with an HF radio, especially in the car when it's not running, you'll definitely notice reduced power unless you run some kind of a battery booster.
The other thing to notice is that, on receive, it will usually be fine at, down by 11 volts. But as soon as you start transmitting, you run into all kinds of trouble. And especially with sideband, the power draw is actually very nonlinear, right? It'll actually, on the peaks, draw a lot more current than you would, on if it was a solid carrier. And so the capacitors in the power system will usually let you ride those out, but only up to a point. So that's why it starts splattering so badly if the voltage starts dropping. So the long and the short of it is those battery boosters, they're worth every penny. They're about $200 to $300. And especially if you want to keep on running your full 100 watts, that's the way to go. Of course, you also run the risk of actually ruining your batteries in the process.
Lithium helps too, because the nominal voltage on a lithium pack is usually a little bit higher. The other thing I would say, right, this is really, really dependent on the equipment you're trying to run. So measure it, right? We just talked about how to measure power output. Set your power supply to 11 volts and measure it. Set it to 12 volts and measure it. Set it to 13 and measure it. And characterize your equipment. I probably wouldn't recommend doing anything that's really, really outside the specifications, because that's a good way to burn things up. But yeah, try it and see.
For example, my Yaesu radio says, don't go over 16 volts, you'll damage the equipment. Well, at least not for very long.
There's always engineering margin too, but yeah. Probably on the high end, but yeah.
The SAMlaxes, there's actually a little trim pot that you can set the voltage at. So instead of, it comes out of the factory at 13.8 or so, but you can turn it up to about 14.5 or so, no problem.
The other thing that can happen too, if you have lots and lots of wire between your power supply and your radio, there's loss across that as well, depending on how large it is. So maybe your power supply is putting out 16, 18 volts, but you're still only getting 13. So that's another thing to think about as well. Getting back to batteries, well, how do we test batteries? We apply a load to them and see what they do for a while, right? And you can buy devices to do this. I have one of these, but it's a resistor and a fan and a computer to tell you voltage over time. And how big of one of these you need depends on how big a battery you want to test. So these come in sizes. And batteries age, right? So it's nice to be able to characterize your battery and say this battery is good or that battery is not good. I suppose if you have a car battery, you can take it to AutoZone and have them do it too. That's kind of the budget approach. And I know the RC community has a bunch of battery testers too, so that might be another angle. Yeah, anyway, apply a load. It's a resistor, a heater, preferably a load that doesn't do anything strange, like depend on how much noise Willem's making. And monitor the voltage over time and compare it to the original specifications, or again, whatever your expectation may be. Maybe you know this is a 20-year-old battery and you expect it to do half its original specifications. It's fine, but have expectations and know what the system should do.
On the lithium question.
Microphone. Get Willem some exercise.
As well as any experience, last summer I took a trip and I decided 11th hour to get some lithium AA batteries because I have a handheld GPS and so on. And so charged them up. They got like USB-C to charge them up. Okay, fine. And boy, doing great. And then the screen's blank. I mean, it's after several hours. And my experience with alkalines was, yeah, I get a little bit of a, hey, we're going down, here we're going down, here we're going down. I was wondering if there's any experience that it just drops off like a cliff instead of having any kind of gradual degradation.
That is absolutely how lithium works, and that's why radios like lithium, right? Because you get that nice high 13-ish volts until all of a sudden you don't. And you don't need the battery booster as much, where you're trading current for voltage. Yeah, so the lithium, the discharge curve is kind of a sigmoid. So you start out pretty high, and it drops a bit pretty fast, and then it plateaus for a long, long time, and then drops off a cliff.
Okay.
And shortly after dropping off a cliff, if you have a good lithium battery, the battery management chip in it will totally cut it off, because if you take a lithium down to 0, you will kill it.
Oh, okay.
Yeah, and sometimes if you're doing like car battery style lithium, a lot of times there is some procedure to wake up the battery manager after you have discharged it too far. So that's something to be aware of. If you take a lithium battery down to dead and it stays dead, there's often some way to resurrect them, because that's really the battery management chip going into a protection mode. Yep, I've hit it with the RV batteries too. So you can get a fancy charger. I think in a lot of cases they just feed it the high end of the charging voltage for some period of time to wake them up. But you know, there are different battery management systems, and who knows what your particular battery may have. But that's why when we're testing batteries, we want them under load. We want to monitor them over a period of time to make sure that curve is what we expect. Whereas if you have an alkaline or a lead battery, we would expect the voltage to drop slowly over time. And again, if you're testing lead batteries, probably don't want to test them below 50%-ish charge, because you will kill them. Lead batteries usually don't have that battery management system in them, whereas lithiums do, because lithiums like to catch fire when you do bad things to them. Not that lead batteries won't, but the lead battery is probably going to splatter you with acid and hurt you. The lithium battery, go YouTube lithium battery fires. They're pretty impressive. Yeah, so again, know what you have, know how it should behave. So anyway, let's say we're good on power, right? We've load tested our batteries, we've recharged them after load testing them. Watch out for that. All is well. So what else could be wrong, right? Well, how about the antenna? Same way we did the dummy load, right? Connected to the VNA. You should see about 50 ohms of impedance around the frequency you want to transmit on. Now, this is something that new hams sometimes get confused about. It doesn't have to be exactly 50 ohms. It doesn't have to be exactly a 1-to-1 SWR. Like anything else on your radio, there will be a spec for this. And a lot of times, 1 to 1.5 or 1 to 2 is totally fine. Maybe it's not the most efficient. When you're reflecting power, you are turning some of that power into heat in your coax, which obviously is not the most efficient way to do things. But you probably won't hurt anything until you get those numbers pretty big, especially for modern radios. If it was made before I was born, your mileage may vary. I'm not going to admit to knowing anything about that. And such devices are fairly common, I think. Go for it.
5. Richard from Aries R1D5 says, power out is a function of power in and efficiency of the equipment. Remember, power equals VXI.
Absolutely. And that efficiency of the equipment is usually 50% or less for radio equipment. So that's why things get warm and have fans, right?
Transmitter shows good SWR. I've had that happen before, where there's a bad connection or a little corrosion, and the receiver, it doesn't receive worth a darn.
Yeah,
Put
so
1,500 watts out in it, it works fine. So
I will mention that. Yeah, corrosion is another word for capacitor or resistor, depending on the particular corrosion. So yeah, if you can produce something that looks like a 50 ohm resistor, you've made a dummy load. If the energy is not getting to the antenna and the antenna is not such that it's going to radiate, you may still have good-looking properties to a VNA or your radio system, right? It matters where you measure. And that's a great point and not one I really cover very well. So measuring at the radio may be different than measuring at the antenna. Why is that? Well, because there's this big piece of coax that, is it coax? Is it actually transmitting the energy, or is it a big resistor? I mean, really, realistically, it should be some of both, but yeah, that's absolutely something that can trip you up. It comes with tuners too, right? It's often better to put the tuner near the antenna so that you're not losing as much energy in that coax. So yeah, and it also comes back to being methodical, right? It matters where you measure, it matters how you measure. But this is a good heuristic. None of these measurements are perfect. None of these things are perfect. But if you stack them up over time, you know, you've measured it. You've measured reflected power at the radio. You've measured reflected power at the antenna. You've measured that the coax is actually coax. You've measured, you know, by the time you start eliminating things, sooner or later you're going to find your big problem. Hopefully. I mean, every now and then we just don't understand things and we give up and throw stuff in the junk drawer, but if you're stubborn enough and you measure enough stuff, sooner or later you'll find the problem. The other thing that can happen, right, antennas are tricky. So an antenna is an antenna system. It's the coax, it's the antenna, it's where the antenna is placed. How close to the ground your dipole is changes the property of your dipole and how long it needs to be. So, you know, somebody standing next to your antenna changes the property of your antenna. You need to be very methodical. You need to make note of all the details of your measurement because some of these things can matter. Someone leaning against the antenna really makes a big difference to your antenna. And if you try transmitting, it will make a big difference to the individual and they will learn the mistake in their ways. Not recommended. We have RF safety regulations for a reason. Tree branches. And tree branches don't scream like people do. They do catch fire. Yep. But yeah, I mean, it comes down to controlled experiments, right? Know all the things that could be part of the system, as much as you can. Again, none of this will ever be perfect. So antenna testing, right? Reflected power can be a good indicator. If the reflected power is really high, something is probably wrong. If the reflected power is good, I don't know. But at least we've eliminated something, right? So what else can we do, right? Well, there's a really easy way to know if your antenna is working, right? Phone a friend, send them down the road a bit, and ask them if they can hear you. Make a test transmission. You can also get a field strength meter and walk around the antenna and try to see what you're radiating. Not something I've personally ever really played with. Theoretically should work. Expensive. Probably easier to just make friends with another person with a radio. After all, we are trying to communicate here. One nice thing, though, that's come up lately, and I don't know if anyone made my SDR talk last year, web SDRs. You can borrow other people's radios through the internet and maybe hear yourself. So if there's one nearby, you can make a transmission and listen through your computer, someone else's radio, hopefully an appropriate distance away, see if you're getting out that way, which is... Oh, absolutely, yeah. Google Kiwi SDR. Kiwi SDR, like the fruit. There are hundreds of those that, you know, hams have bought up and put on the internet, and you buy one of those, you plug it into the internet, and it registers itself by default with this registry of web SDRs. And, you know, you can, they support like 6 people listening to them at once, and, you know, you go on that registry and you find one that's wherever you want to test from and listen. Or for those of us who live in a poor HF environment, you just use them to listen. Because some of these have fantastic antenna systems or at the tops of mountains, you know, whatever it may be, right? It is, yeah. I know a couple of us have been using them for hunting down interfering people as well, right? Because whereas it's really hard to DF from, especially on HF, right? To DF from one station, what if I have a station in every state in the country? And I can listen to them all and do some math and try to find people that way. So there's a lot of that. Having a distributed receiving network like that gives you a lot of power. It's cool stuff. Yeah, so you do your tests, right? You've checked for corrosion on your antenna. Coax is perfect. Everything's great, right? Your hardware is fine. Well, I'm going to say if you say so, because people who say their hardware is perfect are usually wrong. But that's okay, right? I'm a software guy. So maybe we've programmed the radio wrong. Could happen. Probably won't, but I would say for people, like if you pull an HT out of the box, this is what is wrong, right? It's not the rubber duck. It's not, right? The hardware is probably fine. It's the operator. So let's do some things there, right? And kind of the quintessential first thing that could be wrong with the operator is they could be too far from the receiver. And this one is really tricky to measure. This is one of the harder things to measure in this talk, right? And you know, sometimes in the front, along the front range, you can just see the repeater's antenna. This is very easy, right? VHF, UHF, if you can see the antenna, it's probably going to work. And if you know where to look around here, especially we're on the Eastern Plains right now, if you look west and you know where to look, you can probably just see the antenna. So this is, in some ways, less a problem here. But the good news is, well-behaved, polite repeaters can just tell you what they're hearing. So that's a good starting point, right? And this is the status page for the Fun Machine. This is on the public internet. I don't know, is Qualcomm's public yet? That's no fun. But if you don't have the WebSDR and you want to know what the repeater you're interested in is hearing, sometimes they're public, sometimes they're not. So that's a thing you could look at. If you want to go down into the weeds, this is we0fun.com, and then if you click status or system status, something like that, you'll get a page like this. And if you click around on the top, you can choose some of the different receivers or repeaters, and a few of them will have a signal strength indicator like this.
So what would I see if it's working?
Some of the bar would be shaded in. So this is an 8-bit representation of signal strength, so between 0 and 255. And, you know, more is more. Yeah. Yeah, so this is the Thoradin repeater on the Fun Machine. RMHAM, I think, sponsors it still. We did. So if you dial this up on your HT and go to this web page, you should see that bar change as you transmit. And if yes. Yeah.
So what do I see before this works? Does the whole black bar need to turn green or blue? Or will it work if I'm just like halfway up the scale?
I would say halfway up the scale is fine. It's a very analog thing. We're talking about analog radio here. So, you know, if you're pegging it all the way over, then you're probably going to sound good unless you're doing something bad with your audio, which I wasn't planning on talking about a whole lot. If you're halfway across the scale, maybe you've got a little noise or something, but you're probably fine. If it's just twitching a little bit in the end, then probably you're incomprehensible, but you still are probably also at least kerchunking. You know, something should be happening. There's not an exact science here, but it gives you an idea if you're being heard, which is valuable. Those are individual repeaters or PBX endpoints things, right? There is if you just go to this page, it'll give you a list. Like one of those numbers will be Thoradin, one of those numbers will be West Creek, and so on. Or some of them are computer systems where we're transcoding from DMR or transcoding from whatever. It's a fairly complicated system, but this is a handy page. There's another page that has a list of all the repeaters, and we'll just tell you if one of them's keyed too. So that also is an indicator, right? If the line that you think you're talking to goes green, then it's probably hearing you, or it's at least hearing someone. So it's a nice way to get some indication out of band whether something is happening or not. And that's all it is, right? It's not a really precise measurement, but it's better than nothing.
Echo Zero Foxtrot Uniform November.com.
Yes, sort of. That will give you some information about this repeater system, and then there's a status button you can click. I'm sure these slides will get published somewhere, and you can steal that URL if you really want to. But it's not difficult to find. And if you key up on the Fun Machine and, you know, ask for help, most likely Jeff or Amanda will come and tell you about this anyway. They do that pretty regularly.
The wrong tone, will it show up in this particular graph or not?
It will not. But there are other ways of knowing that, which we will get to. Less of a measurement and more of a simulation. If you really want to get fancy and go into the weeds, we can try propagation modeling. If you know where the repeater is and you know where you are and you know some soil properties and how far off the ground the antennas are and a bunch of other fancy things, you can get a pretty good idea of how far those two signals are going to propagate. Of course, things like the weather play into this, but you can get a pretty good idea. And you know, this is not an exact science. These are models, right? They're representations of how we understand the world to work. They're not perfect. They're not a measurement. However, they can be a good indicator of whether the system should work or not. And I don't really have a better proposal for knowing whether you're in range of a repeater. Many repeater systems will publish maps generated by these tools, one or the other. So you probably don't actually have to do this work yourself. You know, it'll show a relative strength mapped over some region around the repeater system. And you can get an idea whether you are standing in that region where there's enough signal strength to be heard. But it's a cool piece of math to play with. And if you're playing with Splat, the results look kind of like this. This is an event that Willem and I did, well, actually the last few years, right? Where we have a repeater system up here on a hill, and we have a bunch of people at different spots inside a canyon. And it mostly doesn't work, but we can see this purple color is, the purples and the blues are RF signal strength. So we can see that most of these sites have just a little bit if you stand in the right place and kind of do one of these deals. So this is a nice way to get an idea whether the repeater will meet our needs without having to go hike through a canyon an extra time in advance, which we of course did, and we had a lovely day doing it. But you know, it's another tool, right? Should my system work? It sets expectations. Should it work? Well, maybe. Should it work well? No, because gray is nothing, right? And it's not perfect. I would say that this underestimates signal strength a little bit in this environment. But I probably didn't pick the right soil type or whatever, you know. Do you know exactly what type of rock your ground is made out of? I don't.
Are we on the air here?
You are, Doug.
Hey, just as a comment, and John and I were talking about a physicist who kind of coined this phrase, but remember this is a prediction or a simulation, and you have to make sure your predictions match reality. Mother Nature cannot be fooled. And a lot of these programs, especially Radio Mobile by Roger Coudet, you can put in an infinitely artificially good receiver and push the coverage of your backyard repeater to the equivalent of Pikes Peak. So just be careful the values you put in, and Ben puts in good values to get these. But if you don't, you're not going to get reality. So
You're not going to get reality anyway.
just remember what you're putting into the tool.
Yeah, absolutely. Right. The assumptions you make matter. And in the theory of, or in the theme of the troubleshooting talk, right? Your expectations matter. So
Exactly.
you're feeding a model with what your understanding of the planet is, and it's spitting back some calculation based on its understanding of the planet. If either of those is wrong, you're going to get garbage. And a lot of times the correct values are not known. Like I said, I don't know what type of rock that is. And that's a parameter because it matters how moist the ground is, what type of material the ground is made out of. If you have a bunch of really iron heavy rock, then that's going to really mess with your results compared to a pile of sandstone, right? All of these things factor into this. So this is art as much as science. And of course, I have a lot of modeling education, so I can make smart guesses sometimes, a little, sometimes. But it's a tool, and it's something to play with. And if you experiment with it, maybe you can find out the parameters for your area experimentally, because you can try some parameters and see if this matches something model an environment that you know really well and compare. Of course, it will matter, if you move that understanding somewhere else with totally different geology, then start over. Willem?
So, so Radio Mobile actually has a very good point-to-point tool. So you can actually, instead of trying to get a general map like this, try to figure out how you go from point A to point B and whether that's a viable path. And most of the time, that works really well. But apropos war stories, we had a situation last summer where we were going to go from one point to the other point, and Radio Mobile said everything works just fine, but the path wouldn't work. And of course, climbing up the tower, you see, oh, well, in the near field, there's this giant chunk of granite right in the middle of my path. And it doesn't resolve at that very local scale very well. So, it's always a prediction, and sometime reality gets in the way.
I don't know what Radio Mobile uses, but SPLAT generally people use from the early 2000s laser ranging measurements from the space shuttle program. So, you might have 1 or 2 data points in a kilometer. So it's not super, super high resolution. It's not going to know about the tree that's grown up in the last 20 years. It's not going to know about small geological formations. So, yeah, it's a model. Of course, one way to solve not having a strong enough path is to just add more power, right? No? No chuckles, really? I tried. Trying to offend everyone, right? We got the Motorola group, we got the Bofang group. Yeah, adding more power probably won't help, because even if the repeater can hear you, if you can't hear the repeater, you're not communicating. So you're better off playing with bigger antennas or better antennas. More power can have value sometimes, but it's not a starting point, I would say. All right, other things that can go wrong. Are you even transmitting on the right frequency where the other side is listening? Are you sure? You're really sure, because the user interface on these radios can be tricky. Well, did you test? So how can we test? Well, do you have another radio that's programmed correctly? Can you borrow one? If so, many of these radios have a button that will put them in reverse mode for a repeater, where you are listening on the frequency that the repeater is listening on, instead of listening on the frequency that the repeater is transmitting on, which is what you would normally want. So, do that. Walk a couple hundred feet away, because if you put the two radios right next to each other, it's kind of like screaming in somebody else's face, right? You're not actually getting much data across. You're just getting intensity across, decence in the technical term. And can you hear the other sides, right? That's a pretty good indication that things are working. If not, well, we can try to make some more measurements, right? Or the WebSDR thing. So anyway, repeater basics, right? When hopefully people come across this pretty early in their radio careers, but repeaters are usually specified as a frequency, a tone, and a direction. What that actually means, the dial frequency is the frequency the repeater transmits on, so that's where you want to listen. The direction is where you want to transmit, some standard split away. So and these are just defined by convention. There's no technical reason why you have to do these numbers, why the transmit and the receive frequencies have to be split by a certain amount. These are probably defined by how easy it was to make filters at some point in the past and how big the bands are. But for now, they're just things to know. So you listen on one frequency, you transmit on another frequency, some standard, usually some standard distance away. Make sure you're inside the band as you're programming the radio, because you may think you're on one frequency, but you're really 5 meg away because of this repeater split thing. Yeah, and this is kind of per band, per region. I think there are probably some frequency coordinators in the room, or past frequency coordinators in the room, that might have some say on how this was set up. Yeah. Radio people are terrible at user interface. So who knows? It's dependent on the equipment you have. Read the manual and hope it was written in English and not Chinese English, or oh, right, this.
I was about to tell you a war story about this.
Yes. We'll let Willem do this one.
3 years ago, maybe it was 4 years ago, when we were last in Silverton, we were supporting a race in Silverton, and I had this handy little VX8 radio with me, and we had designated 146.100, as I recall, as the simplex frequency we were all going to talk to each other. So I tuned my radio to 446.100 and walked down the path and sat on a rock waiting for some runners to show up. And the runner didn't show up, but a bear did. And he was wandering down up the valley, and I was looking at him, and it was just fine. And at some point, he decided to come right at me, and I was saying, "Hey, bear, I'm here." And of course, you know, they walk with their heads down, so they don't see very well. And I was saying, "Hey, bear." And in the meantime, I'm trying to call Dick on my trusty VX8 and say, "Here's a bear here." Well, after a while, the bear heard me and looked at me and went another way. It was fine. But, you know, I was talking like this into my radio, and I could see the red light come on that I was transmitting, but Dick wasn't answering me. Well, it turns out that my radio was set to ARS, which stands for automatic repeater shift. And so when you tune in Colorado to 446.100, which is a simplex frequency, the Yaesu radio thinks that's a repeater. And so instead of trying to transmit on 446.100, I was transmitting on 441.600. Oh, sorry, I got my frequencies wrong. 441.100, right? Still in the band, but the radio thinks I'm on a repeater. And it's applying that repeater shift automatically. And it does show you on the dial that it's actually changing frequencies. But if you're talking into the radio like that, you can't see the dial. So, well, you know, that was a little bit of a distraction. But the long and the short of it is, you know, it's as simple as when you key up, at least look at the radio and make sure that it tells you what frequency it's transmitting on, and is that the right frequency. And of course, the same thing could happen on the repeater, right? You could actually be in simplex mode, and if instead of somebody coming up on you and saying, "Hey, dummy, you're transmitting on the output," the repeater won't hear you, or nobody will hear you, right? So that's one of the sort of pitfalls of Yaesu radios, is that that ARS is very convenient in most cases, but because their band plan doesn't agree with ours, sometimes bad things will happen to you. So again, you know, didn't do it a second time the same day, but at least I did it once on that day.
I've done it too.
Why were you
To add
using
to
a
that-
Yaesu as bear repellent?
I guess one thing I was, going to add to that, especially on UHF, the band plans are different. I mean, for UHF, you look at the shifts here, what's input and output, and compare it to New Mexico, it's different. So, yeah. Well, one of them's upside down. So when you, okay, Willem says that we're right. So that's one thing that I've never been caught with, is programming, everything wrong, looking at hey, am I programming it from the repeater side or the radio side? And to find out that I've got New Mexico backwards. So, look at your frequencies and again, with some of the automatic repeater shifts.
It's definitely helping, though. The Yaesu is helping us. I mean, it doesn't know where you are, probably. It depends on the radio, but yeah. Again, Yaesu's expectations are different than whoever the frequency coordinator is these days. But we're right. Willem said so. Just out of curiosity, why are we backwards? So, Willem's point of looking at the display on the radio is a fantastic one, but sometimes you really want to make sure you completely are certain you know what the radio is doing, because we are so bad at designing user interfaces on radios. Don't understand this at all. So we can make some measurements, which I hope is turning into a theme here. Spectrum analyzers used to be really expensive. They're not anymore. You can get one of these cute little tiny SAs for $100, a couple $100, depending on which version you get. A quick note about that. During this talk, I discovered that these are fairly low resolution, so if you want to resolve audio in your signal, they probably won't do it, but they are still phenomenal pieces of test equipment and very, very cheap for what you get. So they blow up. If you have a very expensive oscilloscope, and depending on the frequency. At HF, absolutely. Most oscilloscopes. So oscilloscopes have a bandwidth, right, and a sample rate, so they can only resolve up to some frequency. If you have $100,000 and a 5 gigahertz oscilloscope, yeah, absolutely, you can resolve whatever you want below 5 gigahertz. If you have a 30 megahertz cheap USB scope from Amazon, try not. So spectrum analyzers give you frequency over time, and typically will resolve higher frequencies, but you don't get to look at the actual waveform. Everything is just assumed to be a nice clean sine wave. Your oscilloscope will resolve whatever waveform, but they typically are lower bandwidth. And both have bandwidth, how the spectrum analyzer, how small a bucket of frequencies it will resolve. Higher bandwidth test equipment is more expensive. That said, buying a couple hundred megahertz scope is someplace between hundreds of dollars on eBay or Hamfest and a few $1,000s these days. So you can get something pretty nice without spending too many orders of magnitude more than an HF radio.
And there's also some frequency counters and some things that way you just turn it on if it covers your frequency, and it's got some accuracy as well.
Yeah, frequency counters are a thing too. I've never had much luck with them, but theoretically, sure. Web SDRs too. Your $10 web SDR, or your $10 TV tuner SDR from Amazon, the RTL family TV tuners can be tricked into being SDRs. With the right software, that can also pretend to be a spectrum analyzer, and that can work pretty well too. All of these devices, though, if you feed 100 watts into them, they will blow up. If you feed 5 watts into them, they will probably blow up. So,
well, and many modern radios actually can have like a spectrum scope display, either in the display or if you attach a screen, and you can actually, if you listen with another radio, can actually see where you're transmitting, as long as you don't overload the front end.
yeah, good fancy modern SDR-based radio. Absolutely a piece of test equipment, and probably calibrated better than your Amazon oscilloscope.
897 radios from 20 years ago have a spectrum mode where they'll actually show you where you're transmitting.
Yeah, use the gear you have, for sure. Yeah, that gets back to this too, right? Consider what measurements you think you might need to make and buy appropriately. But yeah, their test equipment goes up in price extremely rapidly. So, you know, these tiny SAs are on the order of hundreds of dollars. A low-end real spectrum analyzer or scope, it might be a couple $1,000s. And then if you want to buy lab-grade equipment from Agilent or one of them, you're in the tens of thousands of dollars immediately on up. But you can sometimes get them on eBay for next to nothing. So that's kind of nice. I used one of these for this talk, just to give you an idea what a slightly more capable but still sort of affordable option would be. A little bit more resolution. Actual user interface, right? The tiny SAs are great, especially for those of us who are backpacking to radio sites. But this has buttons. I like buttons. Yeah, and 5% off. 5% off some arbitrary number, but and I will say, without imposing any legal obligations on myself, you may want to Google these because you may find that they're pretty hackable and the hardware is quite a bit more capable than the default license on the software. So, how do we use this to make sure we're transmitting the right tone? Well, we're going to replace the antenna with appropriate attenuators. So any good piece of test equipment will have a big warning placard next to the connectors that says, do not feed in more than X voltage, X current, X power, whatever. They're serious about that. And if you have a multi-$1,000 piece of equipment that you're going to throw your 100-watt mobile into, you're going to have a bad day. Don't do that. Test equipment will also typically have safety limitations. You know, there's oftentimes a category where if you feed more energy than whatever that category specifies, the fire comes out, or you know, it does something life-threatening. So be aware of those limits as well. But we're going to plug in the spectrum analyzer to the antenna port through an attenuator, several attenuators, a pile of resistors, something to make the fire stay in. And we're going to make a test transmission. And we're going to look at what the spectrum analyzer hears. I mean, the spectrum analyzer is a fancy radio in some sense. So we're going to make sure that the spectrum analyzers, you know, you'll see a block of frequencies, right? We don't transmit on one frequency. We transmit on a band. So you'll see a band, and it should be centered about where your dial frequency on your radio is. If it's not, and you're not using some old tube radio that drifts with temperature a whole bunch, then something is wrong. And how did my slides get out of order? That's no fun. Hang on. All right, well, we'll just go with it. Coming back to spectrum analyzers in a second, we'll just say that if you have squelched your radio, you will not hear audio. That's a thing to turn off, for testing at least. And then tones, right? So center frequency, another thing you might want to measure with your spectrum analyzer is whether you're on the right tone. And this is another thing, radio people are so bad at user interface. You know, you've got your CTACSS or your tone, or you might have a transmit one and a receive one, and you know, you might be using a Chinese radio that uses the term CTCSS somewhat creatively. There's a lot that can go wrong here. So again, it's worth measuring exactly what happens. Same setup with the spectrum analyzer, and I'll have a picture here in a minute, or listen to the audio with your WebSDR, do something called a fast Fourier transform on it, which basically takes your audio and turns it into the output of a spectrum analyzer. Yeah, and modern radios typically won't be generating the wrong tone, but you may have told it to generate a tone you did not intend. Old radios, I don't know, your crystal could be cut wrong, or the temperatures are wrong, or, you know, things happen. So anyway, this is what this looks like. And yes, I know I'm supposed to remove the screen protector. The screen protector says to remove the screen protector, but I like protected screens. We are feeding just an FM carrier, no audio, into the spectrum analyzer here, and we can see this pretty small band of energy. And we're centered, the spectrum analyzer is centered roughly around the transmit frequency of the radio. It's not perfect. I just dialed it in with the click wheel because typing 10-digit numbers is irritating. So if we turn on a tone, though, the output looks like this. And this is a screenshot captured through the network because pointing cameras at devices is painful. And this is a cheap Bofang radio because I didn't want to blow up a nice one while I'm key down for 5 minutes trying to take screenshots. The tiny SA, like I said, doesn't have enough resolution to resolve these sidebands, so you wouldn't get audio. On the tiny SA, it would just look like a rectangle. So you'd be able to verify that you're on the right frequency still, right? So the dial frequency is going to be somewhere around the middle here, hopefully. And we can turn on markers pretty much every, yeah. Yeah, yeah, the resolution is, I think, is it 2 kilohertz, something like that. So you get a pretty good idea. You can measure deviation with them if you're careful. It's tricky to measure audio like this. So again, it's a matter of how far in the weeds you want to go with your measurements. And even being able to measure deviation tells you a lot and is enough to kind of tweak your audio and that sort of thing. Yeah, so this is frequency and energy. The energy scale is a log scale, as things typically are in radio. We would generally turn on markers, so these guys are markers, and it will tell us what the value is at these points, and you can click the points around, and pretty much all modern instruments will do that. So if we pick the distance between two of these sidebands, we measure it at 72 hertz. And you can see that I have told the Bofang to put out 71.9 hertz, which is, close enough. These have finite resolution. The measurement tool has finite resolution. The Bofang probably has finite accuracy because it's a $30 radio. So between the two, that's pretty good. You saw in the other picture, I have connected a bunch of adapters and a 30 dB attenuator. So if you're trying to take pictures with one hand and, key down with the other hand, the attenuator gets quite warm. So that's another thing to consider when buying attenuators. But yeah, and I probably have the Bofang in low power mode. That was the intent, but the menus are in Chinese, so I don't know. You could figure that out by doing the math on the different attenuators. Yeah, it's the distance between the sidebands. And because I'm bad at this, and I haven't taken a class in RF in 10 years, I'm going to prove that to you in a minute. Because I wasn't that sure either. And so pretty sure that's how it works. And the spacing, you can pick whichever ones, right? This is a nice example because there's no modulation except that one tone. So it's pretty clean. All the sidebands will be the same-ish. Yeah. So how do we prove that this is not a fluke? To your point, right? Well, pick a different tone, do the same measurement. Did it change? And sure enough, yep. And I probably don't have the peaks quite exactly dialed in right. So again, 101 hertz is pretty much 100 hertz, whatever. And I also turned down the resolution. So yeah, these spectrum analyzers are sampling different frequencies. So it will take a very long time to draw the trace at maximum resolution. And that's something you pay extra for in a spectrum analyzer. This one is not super fast. If you want one that can do 1 hertz resolution in sub-second time frames, go trade your car in for it. But as a ham, this tells me a lot, right? This tells me that I'm getting the tone out I want. This tells me that if I move the marker here, the frequency I'm on is whatever that ends up being. It's between 146.53 and 146.54 to give you an idea of what the whole scale is. So we're pretty on frequency. We're transmitting a tone, doing the right thing. If we manipulate the menu that we think should change the tone, it actually does. So we've eliminated a whole lot of very common possible problems. On the other hand, we've used a $1,000 piece of equipment that we may or may not have. But troubleshooting is a scale, right? You do the easy stuff, like look at the display and see if the display says you're doing the right thing. And if that measurement, you're absolutely certain everything is working right by that metric, well, then we can zoom in. And that's where I'm really trying to go with this. And yeah, same setup, no tone. And as we end this section, a couple more dumb heuristics, right? And this probably should be at the beginning. Things to check first. Did you turn the volume up, right? I've done this one. Is the audio output going to the right place? Did you plug a headphone cable in and then unplug from the headphone side and there's another cable dangling somewhere you don't know about? So the radio thinks it's sending to a speaker or something and not to its internal speaker. Are all the connectors making good contact? And Willem will have a story for you on that in a minute or a bit. Are you in some funny mode? This is one I hadn't come across that Willem suggested last night. Apparently some radios have a packet decode mode where they will hide the audio from you. So if you're in that mode, it just will choose not to provide you the audio. Might want to turn that off. I know some of the Yaesu radios have some, as it wires X, some fancy internet mode thing that changes the behavior a whole bunch. And it's a button that's easy to hit on the corner that I've never used deliberately, but have used by accident a number of times. And again, as you get to know your equipment, you'll start to know where these common traps are, like that one.
Earlier with this, I mean, a lot of the times, if the repeater does come up and you don't have the audio, you can see some indication on the radio that, hey, you've got some signal, but not all of the repeaters transmit a tone. So a lot of the time is you may accidentally have it turned on the radio. I know you said in some of your troubleshooting earlier to make sure it's off, but I think that's a good thing to check up front, is to get rid of the tone on your radio for received, or to bypass it or hit the monitor mode on the radio.
Yep, absolutely. Anything that is going to hide information from you, you want to turn off.
Example of that. Checking into a net the other night, my audio was terrible. I said, we can hardly hear you. I said, what's the matter with this? Well, the issue is I have a headset with a mic, desk mic, and I was on the headset mic, which was laying over here, talking to the other mic. So it really helps if you have the right mic selected for good audio.
Those of you who live on conference calls like I do, same deal. Zoom will do that to you every time. Oh, I have a Bluetooth device in the other room that turned on. Every time.
Have you ever transmitted on the wrong VFO?
Yes. Yep, I didn't think of that one. That's another good one.
Apropos the last point there, the Yaesu radios, or at least my radios are almost all Yaesu. This same VX8 has an APRS decode filter that goes in line. And when that's turned on, it won't put out any audio to the speaker. So you can turn that on any of the channels, but if you forget to turn it off, you will actually see the meter come up so that it's receiving a signal, but you won't hear any audio because it's being fed to that APRS filter to actually decode the packets. And on analog FM, you're not going to see anything.
And that gets back to looking for things that are happening. I guess situational awareness, right? Sometimes the little green light turns on. Maybe you don't hear any audio, but at least you can see the radio's receiving. Making observations, right?
There's usually an unfamiliar icon on the display somewhere.
That too.
Like the thing on the TM710 that says BCN, that stands for beacon. It has nothing to do with bacon.
Bacon.
With FT8, There's 2 time slots, the even and the odd. And there'll be a DX station on and people calling them, and there'll be people calling them on the same time slot that the DX station is on. I'm sitting there, who are they hearing? Because they're transmitting on the same slot that the other station is, but they keep calling and calling. I don't know.
Yeah, I don't know. Any other suggestions while we're here? It's always fun to, this is a super hard talk to write. 'Cause how do you enumerate all the things that can go wrong?
Foolproof because fools are so ingenious.
On that note. We'll have to get the rest of the people in the room to be quiet, but yeah. All right. So I'm going to be honest, this one is a little less fleshed out because I ran out of time, but it is such a common thing. I know some of the local areas groups have been on a packet radio WinLink kick for the last year, so I figured we'd try to cover it. A little more complexity, but not a whole lot really. And seems to be the kind of, if I can't talk to the repeater as the quintessential new ham experience, this is the quintessential old ham experience. Plus, it's computers, so it's something I'm actually qualified to talk about. So, basics. Technically, this isn't correct, but for the sake of argument, let's say FM radio, VHF, UHF for now. You can do this over sideband, but it's really slow, and I'm choosing to ignore that for now. So you have your radio, and you have some sort of modem. And for those who have been around about my age or more, modems just take bits and turn them into sound. We have typically a protocol called AX25, and that uses two tones, kind of a higher frequency tone and a lower frequency tone to represent bits. It is getting a little bit more popular now to use proprietary or semi-proprietary modems. VARA lately is the hip new thing. Personally, I don't like because it's not free. It is a published spec, so theoretically you could implement it yourself, but it's also a patented thing, I think, so you probably couldn't use it legally if you did so.
Only.
And it's Windows only. I am using a Windows box today, but that's pretty much a presentation thing for me. Or any other transport of bytes. So if you have an Iridium phone, WinLink understands Iridium phones, which is kind of cool. Or regular old TCP sockets, you know, the internet, Wi-Fi, whatever. You can do that too, but in this crowd, I feel like that's cheating. So we won't talk about that. So you have set up your WinLink station, and predictably, it doesn't work. Where do we start? I'd probably start with the radio, which we just spent an hour talking about, right? Same stuff. Probably don't want it in repeater mode, so I'm going to have to win the battle with the ASU. You can test this and have an idea whether it's working because you typically are on a shared packet frequency. In Colorado, there are a couple that are pretty commonly used. I think DRC says 14505. I think Maxwell and Willem are using 1459. Okay. It's just him that's different. Okay. So there are a couple places to look, but there are enough packet stations in Colorado that you will typically hear some packet traffic if you wait a while. Within 10 minutes or something, you should hear it, and it sounds like an old 90s modem. So if you know what that is, you'll know it when you hear it. So that's a good way to know if at least your receiver is working, right? Unplug the modem and just listen for traffic. If you're hearing stuff, probably your radio is doing at least half of the right thing. You know, all the same, check your antenna, all that stuff still applies, and packet is probably a little more sensitive than voice, right? It doesn't like noise all that much. So, assuming that's good, we can move on to more interesting things. A couple common approaches to WinLink or packet radio in general. I'm going to use those two words interchangeably. WinLink seems to be the cool thing in Colorado. Packet radio is the underlying technology and personally more interesting. You can have a hardware modem, right? You buy something from Cantronics that you plug into your radio and you plug into your computer and it converts bits to noises for you. And that's pretty convenient. You can also have a software modem that generates tones through your sound card or some other piece of hardware. You probably have all the equipment for that, except maybe a cable, but now you have more software to deal with. And I'm not going to talk about that a whole lot, but it is an option. In either case, a computer sends data to the modem or the software modem and handles a little bit of protocol framing. Packet radio is a protocol of the 70s or 80s, something like that, right? It is very, very simple, and it's kind of lovely to play with as a modern computer professional, right? Nowadays, you have to deal with SSL and encryption and all this stuff, right? Packet radio it's just text. It's lovely. It depends. That's a very fair point, I would say. They're easier to debug in many, many ways. There is software that will outperform most hardware modems available for free. Direwolf comes to mind. So as far as the signal processing goes, you can probably do better than most hardware modems if you get everything tuned right. On the other hand, you have to get everything tuned right. You have to have a good sound card. You have to know what you're doing. You have to have all the cables wired up. You have to have all the software cables wired up. It's a thing. So I'm mostly going to talk about hardware modems because they're simpler. Trade-offs, right? Like anything else. Yes, that's an even better approach, like the Kenwood 710 or ICOM has something. You just plug a serial cable into the back of the radio and push the TNC button and off you go. That's lovely. Better is subjective, right?
Modems are actually running software in them, right? They may have some hardware filters and things like that, but in the end, they're a piece of software too. It's just that it's in firmware. You turn it on, it works.
Yeah.
Or it's completely dead.
In the spirit of troubleshooting, right? Like I said earlier, the problem is always the connections. So if I have a radio and an audio cable and a modem and a serial cable and a computer and all this stuff, there are more opportunities for things to go wrong versus all of those components being soldered onto a piece of fiberglass and tucked in a nice, robust metal case. Same idea, all of these protocols, right? PACTOR is another one that's, again, another proprietary little box. Pretty expensive. Don't know that it gets used much in Colorado. But yeah, I mean, simpler is better. However, if all else being equal, if you can edit the software, you can make the software better over time, and thus it might perform better in the sense that it will decode packets at lower signal to noise ratios and things like that. So if you want something that's reliable, then absolutely get the hardware TNC built into the radio and be happy. If you want to tinker and maybe have the best conceivable performance, then the software stuff might be a way to go. Or play with both, right? That's always a thing. It's a hobby. It doesn't have to work. In that vein, right, if you do have a hardware modem, you have all the normal things that go wrong with pieces of hardware. Did you plug the power in? Did you plug the radio in correctly? Are the audio levels set right on the radio? Is the software that talks to the modem working? And you know that can be as simple as a terminal emulator, right? But there's still software. Or RMS Express, I guess it's WinLink Express now. They keep renaming stuff. While we're being confusing on terminology, I'm going to say RMS Express, and I'm going to mean WinLink Express. And of course, the hardware modem itself is another piece of hardware that you can break or blow up by leaving in a thunderstorm or whatever. Software modems, what goes wrong with software modems? Well, the software. As a software engineer, I feel qualified to say that software engineers are bad at engineering and should not be called engineers. So software tends to go wrong. There you go. The other big thing is the audio channel from the radio, right? And a popular one, Windows, if you're running a Windows machine or even some Linux machines now, we'll see this as a sound card, right? Because you're using your sound card as the A to D, D to A to generate the sound that you then pass over the radio. And as such, it will try to send alerts, bings, I need a Windows update, attention, you know, whatever it may be, over the air, which will annoy the local ham radio community. Don't do that. Turn off the OS noises before you're playing with this, or be very sure of what sound card is configured to do what. So the thing that both approaches have in common is audio levels. And I was hoping to go take a bunch of oscilloscope screenshots. You'll see the blank slide for it. Time is finite. But in general, if you have your audio levels set too high, then you will have clipping happen, right? You will lose data, you'll lose the top of the waveform, and the other side will have difficulty decoding your packets. If you have the audio signals too low, then your signal to noise ratio may not be high enough. And again, things will not decode very well. So there's kind of a happy range, and one sort of dumb way to set it is to just set it to the point where it clips high and then turn it down a little bit until it stops doing that. If you have a meter on your radio, you want it to be set so that things are not maxing out. And on the receive audio, same thing, right? Look on if you're doing a software modem, look on the computer. If you have a hardware modem, hopefully your hardware modem has a mode where it will tell you what it's receiving a little bit less than all the way on the scale, right? And that'll get you fairly close. If you want to do better, put that audio up on your scope, make sure that both tones are in kind of the same range, make sure that it's a nice clean sine wave. But, if you get it good enough, it will probably work. And don't use compression. Yes, you don't want your radio doing anything to your waveform. You want to just transmit what the computer generates.
So along these lines, I have two war stories. One is a receive story and one is a transmit story. I happen to maintain a piece of software called BPQ config, which is a piece of software to configure one of the common programs that you actually use to forward packet traffic. And I have this one unnamed individual who, in a span of 3 months, sent me 3 error reports that his station was not working. And in all 3 cases, the end of the email exchange was, oh, never mind, I had the volume turned down. On the back of your radio, there's typically a 6-pin DIN connector that will put out 2 levels of signals. It'll put out 2.2 volts peak to peak or 600 millivolts peak to peak. And that's the data port, right? So if you have a radio that says it's a data radio, that's the place to actually pick up the audio. The 600 millivolt is typically pull off of the discriminator, and it's called 1200 BPS on the radio often. And the 2 volt peak to peak is called 9600. It's really the same signal, but the one works better for higher speeds. If you can pull the audio off of there, that's a great thing. Because regardless of what the volume setting on the radio is, that signal coming out of the radio is always the same, and it's always unsquelched. If you're using the speaker audio, you have to fight 2 things. You first of all have to fight the squelch setting, right? So you want the squelch to be open all the time. You don't, the TNC doesn't mind listening to all the time, right? So it's actually good to have that turned off because there's a short delay between the squelch actually being shut off to let the signal through at the very beginning of that packet signal. And if the person on the other side have their transmit key up time set too short, then the squelch may not be fully closed by the time they start sending data, and then you can't decode the packet. The other thing is just, people are in like the comm trailer, they're annoyed listening to this noise, and they just turn the volume down, and suddenly your packet system stops working because the packet radio is not receiving the audio anymore. So that's my output audio story. My input audio story was I had a Motorola radio that on the back has 2 data inputs. One is called microphone audio, and the other one is called line audio, right? So I thought I would be very clever and say, oh, I will feed this radio line audio, because, it's typically going to be that 2 volts peak to peak that it would expect. And as Ben noted, you don't want to overdrive the radio. So, if I drive the microphone, I'm probably going to be overdriving it if I give it 600 volts peak to peak. And so it's going to sound terrible. Well, it didn't work for anything. And the reason is that on those Motorola radios, the audio input is emphasized audio, and the line input is de-emphasized audio, right? So the difference is that the emphasis that is put on an FM transmitter is that the higher the frequency, the more emphasis put, more part of the energy is there, so that when you decode it, that the energy for those 2 tones are the same. Well, if you put it in line audio, then the frequency that goes into those 2 tones are now offset from each other. And that's much harder to decode. And if the receiving station doesn't hear you perfectly, then your packets don't get decoded. So again, only made that mistake once. Haven't made it yet, but watch out for those.
And again, it's beneficial to record what you're sending out and know what you're sending out, right? Whether that's a spectrum analyzer or a scope or a web SDR, whatever you have. But some of these traps are hard to discover until you've seen them before. I guess the other obvious place, and again, look at connections, right, is for between the computer and the modem to go wrong. Start by checking your cable, and serial cables come in a couple different varieties, and they are hardly ever labeled. You've got a straight through serial cable and you've got a null modem cable, and the difference between the two is that the receive and transmit wires are crossed in the null modem. As far as I know, there's no standard that anyone follows for which one you need on any given device. So the dumb thing to do here is to try one of each and see which one works. But, look in the manual. You won't generally hurt anything by using the wrong one, but you won't communicate either. The other thing to do is to make sure that both sides of the modem and the computer agree on serial parameters. And again, there's no standard for this, right? How fast does that communication happen? Are there any sort of framing bits used, anything like that? And of course, the old standard, is there any physical damage? Does your cable actually conduct electricity? I've had serial cables in the bottom of my computer bag for years, and they get used every now and then. After having been mashed by everything I own for years, do they still work? Who knows? The answer is no, they won't work in that case, yes. And you never have the one you want. I've built some pretty crazy things out of like Cisco terminal cables and Ethernet couplers because you you never have the one you want. So for those who aren't computer people, serial parameters, you've got your baud rate, and that's the number of symbols per second, if we want to be pedantic. In serial, it's typically the number of bits per second, but you could imagine that you could have a protocol where you represent more than 1 bit with a voltage level. And this is usually the problem. You don't know what your modem is expecting, or you have set the wrong thing in the software, or the software has forgotten what you set. And again, by setting the wrong value, you won't hurt anything electrically, so it is valid to try all of the options and see which one works, but it's a little painful. And a lot of times if you have a USB to serial adapter, they won't like changing baud rate. So, you'll change the baud rate and then nothing will happen. Unplug it, replug it, now it works. So it's good to know what you need, and a lot of times this is configurable on both sides. So it is very valid for someone to have taken your TNC and said, oh, I need more performance, which they don't because the radio is the bottleneck, and set it to a higher baud rate or a lower baud rate. Watch out for that. Stop bits and parity bits are related to the framing. Basically you have packets between the computer and the modem as well. There are kind of standard answers here that everybody follows except when they don't. So, 1 stop bit, no parity bits, and that's a very solid guess. It won't work every time. People can do strange things with serial interfaces, but it's a good guess. The best thing to do is read the manual and don't let people reconfigure your gear. But it's not always possible.
If you set the baud rate to 111,500, it probably won't work because the baud rate is actually 115,200.
That's true. There are standard values. There's no technical reason you can't have a baud rate of 3, but there are standard values that are worth guessing, and there are a lot of non-standard values that are probably not worth guessing. The only thing in radio that I know of that uses really weird serial rates are the GPS DOs that are used on some of the repeater sites, which are like a couple megabaud. Like I said, USB serial converters are necessary and evil. Many computers don't have a real serial port anymore. If you can find one that does, use it. USB is another packetized protocol, so the timing doesn't exactly work all the time. And if you have a serial device that's temperamental about that, you can have a lot of, try it 10 times and it'll work once kind of things. And often the drivers are buggy, so if you change serial parameters, a lot of times it will help to just unplug it and replug it after changing things. I would say stay off of anything that's generating RF, which is a problem in this context. 30 meters in particular.
It's the USB frequency, so you're transmitting right at the frequency of the USB connector.
Gotcha. Haven't come across that, but makes sense. Ferrite beads sometimes might help a little. Having a well-engineered station that isn't blasting RF at your USB to serial converter helps a lot. Using good cables helps some too, I would think. Shielded cables. The other thing that happens with serial, get the voltage right. So USB is a 5-volt protocol under the hood. At least it used to be. USB-C, all bets are off. So serial back in the day started out as plus minus 15 volts, I think. So a good quality USB serial converter will have the electronics to generate the appropriate voltages. A cheap USB serial converter may decide that 5 volts is close enough to 15 volts and that you'll get the right answer most of the time. And that's actually the case, but not quite as reliable. The other thing that can happen is some electronics don't bother with the voltage converters in the device. So you might have a modem that expects 5 volts, and you put the 15 volts in, and the magic smoke comes out. This is typically not specified in the documentation, so I don't know how you figure this out necessarily. I guess plug a scope in and look. But here's another thing that can go wrong. How do you know if your modem is working? Well, if you have a hardware modem, this is really easy. If you have a software modem, you have to figure out the software equivalent of what you do to the hardware modem, which is often opening a socket to it. But like I said, we'll focus on hardware modems a little bit. So if you have a nice user-friendly, human-friendly TNC, you can open up the terminal emulator of your choice, connect it to your serial port, and you can type C and K0NTS. And your radio should key, and you might even get some banner text back from Willem. And that's all there is to it, right? The classic, like if you have a Cantronics or one of these really fully featured hardware TNCs, the D710 from Kenwood does this. The recent, I know the ICOM HT that does packet doesn't do this. It's a KISS TNC, so this is much more difficult to deal with. We'll get to that in a second. But the protocol is pretty simple. There are, I don't know, maybe 20 commands. You can look them up on the web, or they should be listed in the back of the manual for your radio. C is connect. And you, what was that? Yes, D is disconnect. The other way to disconnect is to turn off the radio. It is good to know, though. There is some handshaking in AX25, so it is good to officially disconnect and let the other side know you've gone away. But it's not the end of the world. Connections will time out. I'm a bad person. Yeah, so anyway, if you get some data back from the other station, good to go, right? We've confirmed bidirectional communications. A couple other things you can do. Most TNCs will have a command like pass all that will give you packets that don't have all the data. Like if the checksum doesn't check, it will still give you back whatever it got. So you'll get corrupted packets back, but at least you know you're decoding partially. So that's a good way to test. And if you're getting half of packets back, or you're getting packets back with bit flips, you know, you'll have a call sign that looks like a call sign, but maybe it's not a K, it's some other letter. You can then go look at your RF system, right? You probably don't have enough antenna to listen to whatever you're listening to. So that gives you a pretty good idea where to look. And it's really as simple as that. WinLink itself is just doing this kind of connection. So if you want to talk to a WinLink station, you find a local WinLink gateway, and you connect to it in this way, and it will ask you for a password, and it wants like 2 random characters or 3 random characters from your password. It gives you numbers, which characters from your password to type in. They make this as difficult as they can. And then the message sending protocol is pretty straightforward. You give it an address you want to send to and a block of text, and that's pretty much it. This is documented on the WinLink website. So it is not difficult to send WinLink messages with a terminal emulator. And then you don't need to deal with all that crazy Windows software that sometimes works when it feels like it. The catch is, if you have a KISS TNC, those are not super hardware friendly. And I think Willem has a comment.
So what I always do is, because I deal mostly with hardware modems, the first thing I do is to tune the radio to the APRS frequency 14439 and make sure the orange light lights up, or the amber light, whatever color it is. That way, at least you know that you're receiving. And that way, you know that the audio path, at least from the radio to your receiver, is working. Because it's always more important to be able to receive than to transmit.
And there is usually traffic on the APRS frequency. There's usually traffic on the packet frequency around Denver. So I've had pretty good luck just listening to the packet frequency around here. But yeah, APRS, I would say, in places that don't have quite as much of a packet network is a good way to go too. Yeah. So the cheaper, or the, I don't know, more modern, I guess, both, type of TNC uses a protocol called KISS. And this is more of a machine-readable kind of protocol. So it's easier to write software against, but it's not as easy to just connect to and talk to. There are some pieces of software like BPQ that Willem mentioned earlier that can take a KISS TNC and emulate a real TNC. So that can be a way to go. Or if you are using something like the WinLink GUI, you can tell it, hey, I have a KISS TNC, or I have this model of KISS TNC, because there's a standard, but you know what they say about standards. Everybody has to have their own. And the WinLink GUI should be able to do this as well. But you can also go look up the KISS protocol and figure out the couple of bytes you need to send to get it to key the radio and get it to decode packets. If it's decoding packets, you should at least see stuff over the serial link. It might not look like text, but there should be stuff. Yes. Yes. Whichever computer I happen to have within arm's reach. Sometimes. I have. Windows has a couple of flaws here, especially if you have a software modem, in that it likes to do what it likes to do on its own terms. If it wants to update right now and you're in the woods on a no connection, or like a satellite connection that RMHAM does a lot, that's a little rude. So if you're doing kind of the MCOM thing, there are downsides. Linux does what you tell it to do, which is nice. But that said, yeah, I mean, I work in computers. I have a FreeBSD machine at home. I have 5 different variants of Linux. I have 2 Windows boxes on the table right now. I can deal with whatever. There's probably a Mac in the backpack. It really doesn't matter that much. Obviously, the WinLink GUI itself was written for WinLink, or for Windows. but there are some very good alternatives. I believe we have one of the authors of PAT in the back of the room, which is a kind of web-based WinLink client that works very well on Linux or whatever you happen to have, and is open source, and I would probably shove you in that direction. And I think I have a slide that does so right here. So that said, it's a little bit whatever you're comfortable with. If you grew up around Windows and you've only ever used Windows and you're comfortable with Windows and you know how Windows does serial ports, by all means use Windows or whatever Unix variant you like. It doesn't matter, right? You're sending text over a serial cable. They can all do it. Is that an adequate non-answer? Please no.
I asked, I've got a Linux box right next to me. And problem I have with Linux develop. Sometimes rarely.
If you have a hardware TNC, I'm gonna go against the local area's orthodoxy here and say I find it easier to just open up GNU screen on the serial port and type commands at the WinLink, into a nice full-featured hardware TNC, and just paste text into the terminal emulator and be done with it. That said, not everybody lives in the terminal all day long, 24/7. So that might be a me thing. If you're more of a GUI person, I would look at PAT. You can run WinLink Express in Wine. I would say I've had mixed luck with Wine. It's probably not the most robust, reliable thing in the world, but it can be made to work. I don't know, pick your poison. Yeah, so I think we hit the first point to death here, but shameless plug for that. There are slightly different ways of talking to modems. Each modem might have slightly different implementations of the standard. So things like WinLink will often ask you what type of radio you have, and we'll be able to use that information to sometimes even do things like set the frequency that your local WinLink gateway is on, which can be convenient or can cause trouble. Keep an eye on that, but also to understand the quirks of your particular modem. Actually, if you're on Linux, BPQ is another thing you could look at. Yeah, and as far as debugging goes, RMS Express needs to know all the same information that you would need to know to do this by hand with a terminal emulator. So baud rate, stop bits, parity bits, which serial port you're on, is it a KISS TNC, is it a not KISS TNC, is it a Kenwood TNC or a ICOM TNC, right? Things like that. And if you tell it what you have, it generally works, in my experience, if you have a good RF system. Now, the RF into the USB to serial converter thing Willem mentioned can be a thing, but there are ways of managing that too. And if you're not sure what type of TNC you have, tinker with a few of the common ones and you'll probably find one that works. I mean, the brand names don't matter. It's just they have to be talking the same language. So I would say if you're going to do WinLink for an event, play with it the week before. There is some degree of guess and check here. Yeah, and then the other big trap is make sure you're talking to what you think you're talking to. Are you trying to talk to a WinLink gateway? Is the WinLink gateway listening on the frequency you are on? Do you know what its name is? Right? Are you talking to the right station? Stuff like this. And this comes down to, again, radios and quality user interfaces, lack thereof. Likewise, if you have to go through digipeaters, make sure you're talking to something that's willing to digipete for you. Willem suggested this one is a common trap, and I believe it. WinLink has two modes. There's a peer-to-peer mode and the gateway centralized mode. And I'm just going to skip to the next one here. So up here in the corner, if you're using the GUI, there's a drop-down menu to choose which mode you want to be in. Make sure you're in the right mode. If you're talking to another station without a gateway infrastructure, then you can be in peer-to-peer mode. If you're not, you want to be in this packet WinLink mode. Assuming you're doing packet. If you're doing VARA, you can put it in VARA mode or whatever, Iridium mode. There are a bunch of them. But it's easy to get that changed and not notice. Again, with a quality UI design. So, yep, peer-to-peer mode is great if you're far away from infrastructure and you want to use the GUI. You can also just do, especially if you have a hardware TNC or you have something like BPQ emulating a hardware TNC, you can also just do keyboard-to-keyboard packet. You don't need WinLink involved at all. And I know there are people around the Front Range that do that because I've had a couple QSOs that way. You just send packets out into the ether and see who responds to you. You know, someone might call you back and you can have a conversation just by typing into your terminal emulator. And that, you can still pass whatever data that way. It works great. You don't need these complicated UIs. But again, probably against the local Aries orthodoxy. I think that's all I had, but I will say, yeah, we'll leave it at that, I guess. If there are other WinLink questions, happy to try to entertain them.
Problems is that in WinLink, once if you're actually entering the message as part of the interface, if you set it up as peer-to-peer originally, and you typed in the message, and you then want to switch it to store and forward, or vice versa, it doesn't work. You have to start in the right mode before you start any typing. Otherwise, the message don't go.
There are other alternative clients that are a little bit more friendly. And not just Pat either.
Yes, I should have said RMS Express or whatever it's called anymore.
Yeah, my not used in a year version, I think, updated itself to something called WinLink Express when I tried to get the screenshot. That's another thing too. I've seen if you have people who are using wildly different versions of WinLink, the GUI, they sometimes won't talk to each other peer-to-peer. So again, if you're going to go out in the woods and do something with this, maybe let it update first. Or agree on an old version, I suppose. All right, well, we have half an hour left. Willem contributed one more war story that he actually had slides for. So we'll let him give that. And then we can use whatever time's remaining with questions, or I am sure there are other fun war stories in this room.
Do you have a lavalier that I can...
I guess I should have pre-introduced him.
Are you receiving green? Okay. 1, 2, 3, 4, 5. How do I sound? So I have a story that Chris Keller is to blame for, because he was there. A few years ago, we showed up at the Clear Creek County EOC, where there is this box that are shown here on the right-hand side, where there's actually a really nice setup. There's an HF radio, a VHF analog radio, and a DMR radio, all in this very nice enclosure that usually sits down in a closet. And so, you know, every time that the EOC gets activated, you take that up, put it on the counter, connect the coax in the back, and, you know, it's plug and play. You put in AC power in the one side, you plug in an antenna at the other side, and everything just works. Well, except this time we showed up, and of course our served agency was there, and we said, well, you know, check this out. Key up the DMR radio, and nothing. So what the heck was going on? This thing used to work last summer. Because actually what happened is if you look up here in this valley, what had occurred during the winter is that the antenna is right here up on the top. You can see it's really well disguised because the Georgetown Historical Society gave us all kinds of trouble about putting antennas on buildings in Georgetown. The actual radio room is just over here. And so the antenna cable runs, down here, and then it crosses this valley, except this is Georgetown. So what had actually happened the previous winter was that there was a bunch of snow coming off of this metal roof, and it ripped out the coax. And there's a spot right here where the coax actually enters the building. This is actually a metal face on the building, that there's a polyphaser right there, and it literally ripped the coax right out of the polyphaser. Here's what's left of that connector. It ripped the coax right out of the back of it. And so we had to replace that with this connector. And sort of heads up on the story is the fact that I'm holding this connector in my hand tells you part of what was wrong. But, crimped on a new connector, connected it to the antenna, tested it the previous summer, everything was fine. But come October, suddenly this whole system didn't work. So what the heck was going on? So the symptoms we had was when there was no change in the programming, right? Doug had programmed that DMR radio, so we knew that that was all good, and we had tested it before, and we'd actually used it at the SET the previous year. We could hear the repeater fine, and we could also hear the repeaters on analog frequency. So we know we were receiving okay. But we couldn't hit the repeater on transmit. And actually built into this nice enclosure down here is a very nice honking 50 amp Astron power supply. And when you key up the microphone, you can see the Astron draws about 12 amps. So it's obviously putting out, close to 50 watts DC power. That's kind of what the radio should draw, so we know that the transmitter is at least drawing power. But what are we seeing? Why can't we actually trigger the repeater? So, of course, I ripped out my handy Comet antennalyzer, put the Comet on the connector, looked at the reply that we got back from it, and it shows us about 50 ohms. And if you actually scan, this is obviously on UHF, scan the UHF band, it's pretty nice, quite across, right? SWR is somewhere between 1.5 and 2, so that's actually looks fine. Okay, well, clearly nothing is wrong. Why can't we hit the repeater? Chris even pulled out his Rig Experts analyzer, stuck that on there. That showed good too. So what on earth is going on here? So first hypothesis is it's got to be a bad polyphaser, right? This is on the building all the time. What if there was a lightning strike, right? So what those polyphasers do is that when the voltage exceeds whatever the threshold is, they basically just start conducting and basically shorts out the path. And, if you get hit by lightning enough times, then sometimes they go bad, right? They actually just become closed circuit and all the time actually conduct. And maybe what we're seeing is that when we put the analyzer on it, the analyzer puts out 10 milliwatts, 100 milliwatts, I don't know exactly what it puts out, but a small amount of RF energy, and it looks fine at that. But once you now key up with your mobile and you're trying to put 50 watts into it, then you exceed whatever this is degraded to, and the polyphaser actually sorts out, and when you transmit, it doesn't get any further than the polyphaser. The other thing that's unique about these polyphasers are that they don't transmit DC power, right? So if you actually put a meter on them, they show open circuit, right? So, well, what if we just put the meter on the shield and the center conductor and see what we see? Well, it shows open circuit. Well, what do we learn from that? How much voltage is your DC meter actually putting into that connector? That does it exceed or is it below the threshold of that particular polyphasor, right? Well, I don't know the answer to that, but when I put it on there, at least it showed open circuit. But that doesn't teach me anything, because I also need to know what the characteristics of my antenna was. So if I didn't have a polyphasor in line, but instead I had an alpha delta in line, the alpha deltas pass DC power, right? If I had measured between the shield and the center conductor and I had seen open circuit, what would I have learned? Depends on my antenna, right? Some antennas are actually a DC short, right? Well, in my case, I had an AX50. The AX50 happens to be a DC open circuit, right? So if you actually measure from the center pin to the shield, it shows nothing. So if I had had an alpha delta in line and I had measured from the shield to the pin and I saw the exact same thing, what would I have learned? Nothing, because that's what I expected. Well, maybe I did learn something. I did learn that I don't have a short anywhere on my system. Well, how do I now, what's the next step that I should do? Well, it looks right on DC. It looks right on low power transmit, but I can test my hypothesis that that alpha delta is shorting out on high power by simply taking it out of the line, right? So I happen to have an end-to-end union, took the two ends, had to climb up on the roof, connect the two end-to-end connectors to that union, tested it, can still receive, can transmit. Well, if the union doesn't allow me to actually transmit, the alpha delta is not the problem. Right? So put the alpha delta back in line and start testing other things. So the first thing is, well, clearly my coax is broken somewhere in the middle, right? Should I actually test the upper section or the lower section first? Well, that's arbitrary, right? So since I was already on the roof, I have my antenna analyzer with me. Let me just test the upper section, right? So from where it connects from the polyphasor up to the antenna. So first thing I do, put the voltmeter on it. It's open circuit from there all the way to the top. What did I learn new? Well, because I had a polyphasor which doesn't connect DC through, if there was a short on the upper section, I wouldn't have known that because the polyphasor would have blocked that. But when I basically tested the upper section, well, yep, on DC, it shows open circuit. That's what I expected. So I didn't learn anything. Of course, connect the antenna analyzer to the upper section, and it actually looks just like it did down in the radio room. So I have 50 ohms. I have a good SWR on it. It's unlikely to be the antenna. Could it be bad coax? Right, so what SWR tells you is how much of your transmitted power comes back to your excitation point. If I had coax that was full of water, my SWR would be what? 1-to-1, right? Because none of my transmitted power comes back. It all gets burned up in the water. But the fact that it actually showed 50 ohms told me, well, it's probably fairly unlikely that I have either a bad antenna or a bad coax. What would have been nice is if I could have taken that radio and brought it up on the roof and actually plugged that part of the antenna cable right in there and tested from there to the antenna and see if it worked. But in this case, it happened to have been impractical, just because, you know, the radio is in a box and it's a pain to get out of it. What would have been nice if I had a type N connector to an SMA so I could take my HT and try the antennas at that point. But since I didn't have that to hand, I couldn't do that particular test. So I'm fairly confident that the connector from the polyphaser up to the top of the roof where the antenna is good, and the antenna is good too. What would have been even better is if I could have gotten to the antenna itself and tested that stretch, but that's a hard thing to get to, and I'm afraid of heights. So that didn't happen. Chris is going to turn me into a liar. I'm just adding enough details here to make the story interesting, Chris. It's not the truth.
No, I was just going to interject. We also had the problem that that roof was slick as snot, so that didn't help matters.
Yes, indeed. So given that we've sort of decided, well, maybe the upper part of that connection is good, let's try the lower part. Now, this is actually easier to test because Chris was at the other end of this piece of coax and I was at the other end, right? So now we actually have the ability to test more things, right? So we can do a DC test at the one end of the cable and I can short out the other end, right? If I short it out where I plug into the polyphaser, it's open circuit if I don't short it. It's closed circuit if it is shorted. So that tells me, at least from a DC perspective, that cable is good. Nobody cut the cable somewhere in the wall that I didn't know of. So that helps. The second thing we can do is we can actually put the analyzer on the one end, and we can put a dummy load on the cable on the other end, and see, yes, now it looks like a dummy load, or I can take the dummy load off, and now it looks like an open circuit, and we actually have a good piece of coax there. So establish that the cable is good. Now we can do the same test, screw it into the polyphaser, and do the test at the other end of the polyphaser, right? Now, of course, if we short it on the other end of the polyphaser, because the polyphaser blocks DC, even if you short it, it still looks like an open circuit because the polyphaser doesn't pass DC, but we can continue those same RF tests and basically test from there to the polyphaser open circuit. We should have infinite SWR because all of the energy we send gets reflected back. And that actually also tells us that the coax is good, right? Because if you have bad coax that absorbs a lot of the RF energy, you may get an SWR of 5-to-1 or 3-to-1. Well, the SWR should be infinity, right? Because everything should be coming back. Why did we do that? No, we didn't have an SWR meter. We only had the antenna analyzer, but the antenna analyzer basically said as high an SWR as you actually can get. So we tried that, and that seemed to be fine. Wired up everything again, ran all of the tests from end to end. It still is not working. Okay, we've decided both ends are good. The polyphaser is good. We've eliminated everything. What's going on? Well, you know that because I'm holding the connector in my hand. So, can you zoom in here? What did I do with the other connector? Well, at least the people. So if you want to hear the story, ask the people in the room. It was a great story. So the key here is if you actually look at these connectors in detail, you will notice that on this guy here, that center pin sits back just ever so slightly compared to that one, right? So this is one of those end connectors where the whole thing comes, the whole thing comes as a single body, right? So you put in the coax in here, you solder the center conductor onto here, and the shield onto there, and then once you're done, you just screw on the rest of the part here, and everything, if it screws in all the way, actually looks the way that it should be looking. With a crimp-on type, the center pin is actually a loose piece, and the center conductor is actually, I don't know, that's probably about 1/18 of an inch thick. I mean, it's a fairly big center conductor, but you crimp on the pin, and what I must have done was that center conductor was just a tad too short, so that when I actually crimped it on, it sits back just ever so slightly. And so that was actually what the problem was, is that it just wasn't connecting correctly. So what I have since learned from Doug is that the way that you test a type N connector is you put your finger on the end and you press, and it should hurt. If you take this one and you press on the end, it doesn't hurt, right? And if you actually look at my finger, you will see that there's in the correct, well, let me just press it again. Notice that there is a nice circle with a pin in the middle that, well, if you press hard enough, blood will come out of it. Whereas in this case, if I press there, there's still a little bit of an indentation, but not nearly as much. So, sort of a lesson learned the hard way is make sure that your end connectors hurt you. If they don't, they're probably not going to be working. So, the overall analysis is that this would have been a lot easier to diagnose if we actually had access to the antenna. Because what we could have done in that case is with the polyphaser inline, if we did a DC test all the way to the top, and we had actually disconnected at the antenna and shorted the antenna, with a polyphaser inline, we would have still seen an open circuit. But when we had taken the polyphaser out of line and just put a union in there, then you should see a DC short circuit once you short the far side, right? And so if you actually have access to the far end, this becomes a lot easier because, first of all, you can put a dummy load on it and make sure that your dummy load looks exactly like your antenna does. And if you actually unscrew the antenna, it should go to an infinite reflection or a very high SWR. If it doesn't, then you have bad coax. But with the DC test, what you can then at least establish is that you don't have a situation like what we had here, where that pin just didn't make good enough or didn't make electrical contact at all. But if you had been able to get to the top and did all the DC test, then you would have seen that you don't have an actual electrical path, a DC electrical path on the center conductor all the way to the top, right? And there could have been other things wrong, such as, the coax in the upper end may actually have had a break in the center conductor as well, because in the end, it was snow that took this thing down. And it's not improbable that the center conductor could have had a small break in it, and as the temperature changes and that center conductor expands and contracts, it made a good DC contact when it was warm, But when we were there and it was cold and that conductor had just pulled apart ever so slightly, then you again have that central, that capacitive coupling, not at your conductor, but somewhere on the cable. The long and the short of it is that, you know, this story has a happy ending because in the end, we could tell our served agency, look, the radio didn't work and you had hams here and the hams figured out the problem, right? Never mind that it was the same hams as who caused the problem in the first place, but they were able to figure out their mistakes, right? My shop teacher always said the best carpenter is not the one who doesn't make mistakes, it's the one who can fix his mistakes so that nobody notices. And so in the end, you know, this sort of tale of woe of testing is intended to try to convey the idea, be very methodical, change one thing at a time and retest, see what changes every time you make the test, and try to interpret what that test is telling you.
Into the kit.
And bring an SWR meter, right? It's you know, sometimes at low power and at high power, the answers are different, right? A lot of HF radios actually have an SWR meter built into them, but on VHF, they typically don't. So it's a good thing to actually bring around, and except for the problems with static that Ben pointed out, at least you can get a better sense of what your radio is doing on power.
There's a comment here from Doug, actually a couple. He says, LMR 400, this is less of an issue. The center conductor can still pull back, likely, as Willem said, an improperly assembled connector. He had a similar issue with an 800 megahertz trunk system. The tower crew did not properly clean off the plastic dielectric on the center conductor. It worked for receive, but it didn't pass DC to the tower top amplifier. It was deaf.
So that would have been an easy one to test, right? Because you expect DC on the other end. You could have seen, do you get actually the DC output at the power top amplifier if it's actually working, and hopefully it had an LED that would come on to actually show that it has power. And if you don't see that, even if you can't get quite to it, at least you can tell that there's no power there. So good comment. So we have a few more minutes if anybody else has other good war stories to tell, and I can see Chris is trying to make me into a liar about some embellishments to the story here, but in the end, it turned out well.
No, that was a good summary. That was a tough one to debug. I'm very glad I had you there to know that we replaced that particular connector the months prior.
Well, and again, that's very much apropos Ben's comment of what was the last thing that you changed, right?
Exactly. I mean, I've got a war story I could tell. I think it's about, I don't know, a year or two ago, I was testing a new sound card interface to go between a computer and a radio. This particular sound card interface is called a DigiRig Mobile. It's fairly new on the market. The designer, Dennis KC2VJW, lives out in Grand Junction. Very nice guy. And I was testing some of his early models, and it worked great for my little HF QRP station. I was doing FT8 all day, and that was great. And the great thing about this little DigiRig Mobile is it's so small. It's the size of a small matchbox. And so it was wonderful for HF FT8. And so I got the bright idea, why don't I start trying to do some WinLink with this? Why don't I try some VHF, UHF, packet or VARA or whatever. Started testing it and was not having much luck with it. So I dig a little further. It's transmitting appropriately. I think I'm getting back some information. I'm getting replies from the remote station, so I know it's transmitting okay. All right, so I got to dig a little deeper. Okay, it's transmitting, but I'm not actually hearing a reply. I've got this radio on the side that I'm sort of monitoring the traffic, but the radio that's connected to the computer is not hearing the reply. I had to like mess around with my sound card settings and like pipe it into a recording program so that I could hear exactly what the sound card was hearing before it went into the modem. You know, I had to software tee it off so I could hear exactly what was going on. Come to find out, on this early model of the DigiRig Mobile, if the radio was transmitting at too high a gain, too high a volume, when it would stop transmitting, the sound chip in the DigiRig would shut off. It would like reset for 2 seconds. And so it would never hear the reply coming back. That one was tough to diagnose, and I still don't know how we fixed that on the older models of the DigiRig, but at least I was able to get a reasonably good diagnosis back to Dennis, and I think he's since found ways to mitigate that. So that one was interesting.
So I was actually researching another war story here. You may have read, of course, all of the most spectacular failures make the news. There was a B-17 crash at the Bradbury, Connecticut airport, I think it's 3 years ago now. And what basically happened was, apropos Ben's comment, well, it's got to be the same problem as last time. They had a bad governor on the number 4 engine, and they had been fighting with the darn thing all morning, finally got it fixed, and on takeoff had a problem with an engine. And the pilot decided, damn, it's that number 4 engine again. Basically feathered the number 4, and basically the bad engine was the number 3 engine. So basically lost both engines on the starboard side, which with the B-17 should still be a survivable situation, except they got low energy on the approach, basically ran off the runway and crashed into a hangar and burned up the aircraft. So the long and the short of it is, sometimes assuming that it's the same problem as it was before, and not properly checking that that was in fact the case, sometimes is more dramatic than just that you look bad to your served agency. So use that as a cautionary tale. It's not just always DNS. Anybody else have a war story to tell in the next 3 minutes?
The heuristics, the it's always whatever, are a nice way to save time until they're not, right? So it's kind of things to check first, and then when you run out of easy things to check, then we start measuring stuff.
Nobody else have any cool stories to tell? Well, with that, I'd like to thank you for attending today. We certainly had a good time telling all of these war stories. They are almost entirely true. And I'm hoping that you sort of learned something from it. I think the big takeaway from today is if something doesn't work, it's all about testing, being methodic. Be methodical about your testing, and follow the scientific method, right? Say it may be this. Figure out how you're going to test that it is that, either by replacing the piece of equipment or running a test that will give you the answer, and then just go through it. And in the end, especially in the Aries organizations, that's the biggest value that we actually bring to our served agencies, is that we're not appliance operators. We actually understand our equipment And if there's something wrong, then we can fix it. So with that, thank you all for attending, and we hope to see you all for the next exciting RMHAM University in October.